hit record there. I wanted to quickly go around the room, and if you want to come on mic and then popcorn it to someone, I'll pick on someone to start it off. But I just want to hear your thoughts on the coverage from yesterday or even last night's homework. What's something that you learned or something that stuck with you in particular from Colin's Intro to Databases coverage yesterday, or even last night's homework? So just, something that really stuck top of your mind. So instead of me reading all of the lesson prompt stuff, I thought we'd start with that. I'd love to hear you guys' thoughts. I see David in the top left. So David, why don't we start with you? And then if you want to popcorn it to someone.
From what I learned yesterday, databases takes a really, really long time, just because you have so much to take into consideration, especially depending on what you're working on. When we were working on the library yesterday, there's so much component that goes into it. So that's what I learned. Now I'll pop it over to Alan.
Sorry, could you repeat the question?
Yeah, I was just curious. I'll put it into Slack. I was just curious. I wanted to hear you guys' thoughts. If there's anything, a big takeaway from yesterday, like something in particular that you learned, something that kind of stuck with you as far as database coverage. I mean, databases, we could spend weeks and weeks on databases, right? So I just want to get a sense of what stuck out to you in particular, given what Colin talked about yesterday.
So I guess one thing that I think really helped, this isn't necessarily what you're asking, but
That's okay.
One thing that really helped me a lot was on yesterday's homework. It was a dog has this, and just something about that phrasing made it click in my head really well. So each thing has these things. But yeah, I think that, I don't know, it's a lot to wrap my head around.
Yeah, for sure. Absolutely.
Let's go with Mike next.
Yeah. I think getting to work more with the structures was pretty helpful from last night, getting to just experiment and play around with how the different things relate. I kind of mentioned it in stand-up, but I'm still pretty confused about the level of connected things that you would attach. I guess, for instance, do you have, for the last one, there was favorite team and favorite player. So favorite team has games that they've played. Do you attach all the stats from that game to favorite team, or just a link to a game? So how to approach those different situations.
Yeah, how do you model your data, right? Yeah, I think data modeling is wireframing your data, essentially, right? You're just thinking through it. There's not always a right or wrong answer to structure your data. And a lot of times, hopefully whatever you're building, if you have some sort of business purpose, hopefully that thing takes off, right? So a lot of times I don't even know my data needs or what's going to happen to my app 6 months or a year down the road. I seriously doubt, for example, Facebook or Airbnb had thought that far ahead, right? And that's one of the beauties of a NoSQL database, like Colin mentioned. NoSQL databases compared to a relational database, which we're going to talk about in Unit 4, they're really good for startups, for example, because there's not much ceremony to NoSQL databases versus a relational. So let's say that I'm building an app. I just need to get this thing shipped out over the weekend. I don't have time to, I wish I had time to thoughtfully structure my data and really plan ahead. But sometimes, you just need to get an MVP shipped. And that's a really great use case for the data stores that we're talking about, this NoSQL. It's much more forgiving when you don't have a good structure in place initially. So it's easier to scale up for startups. So if your data needs change, it's a little bit easier to scale up a NoSQL versus a relational database initially. And that's one reason that it's so popular.
I was seeing that on their videos, that it was really easy to add an extra like row of data or something to an existing object.
Yeah, a new field or something.
Yeah. I guess, yeah. Would then all this relation stuff that we're learning or from like last night's homework even apply to Mongo then? Or all like how we structure things from last night's homework?
Yeah, so with NoSQL databases, with most databases, but NoSQL in particular, there's two ways to structure data. The thing that makes Mongo and NoSQL so powerful is that it deals with embedded documents. And that's what we're going to be dealing with today. So for the Mongo coverage, we're going to try to stick to what it does best. But you can make a NoSQL database a relational database. However, I would suggest that if you know that you're going to need most databases are going to end up with the relational, they're going to need to be relational at the end of the day, in my opinion. And so most of the time, it's just easier to use a relational database versus a non-relational database like we're going over. That being said, you can structure a NoSQL database to be relational. By the way, if all these terms and words like are just not making sense, that's totally fine and understandable. We've been doing this a day. Sorry, I don't know if that answered your question. The one thing I was going to say, Mike, we're going to go over all this stuff throughout today's coverage. But the one thing I was going to ask you, Mike, before you popcorn it to someone else, is can you think of an example of a NoSQL data store other than Mongo, other than what we learned yesterday? Can you think of an example?
Like any object, right?
So Mongo is an example of a NoSQL database, a non-relational database, if you will. Can you think of another? So there's a lot of these out there. Mongo is a really popular one, but there are other types of NoSQL databases, other brands, if you will. So can you think of another? It's kind of a trick question because you've already used it.
I can't.
So Firebase is a NoSQL database. Firebase is very, very similar to what we're going to be doing today. It's considered a NoSQL database because it doesn't have a schema or a rigid structure to it. You can add a structure. That's what we're going to be doing today. But yeah, Firebase is a really great example of a NoSQL database that lives up in the interwebs.
Okay, cool.
Cool. Yep.
Sophia. Okay. I have a lot of more of the same off of what Michael and Alan said. I really liked the way we got to visually kind of see how everything was converting to data structures. I think that was my biggest takeaway. It was like a light bulb moment almost. I was like, oh, like this. And then right at the end when we got to the relationships, you could see how there's like multiple relationships for the apps. You could do them in so many ways. And then from there on, it was like adding another feature and what else could you do. So I liked kind of playing with that, moving it around, seeing how if things interacted differently, you could change almost your entire app focus. It was cool.
Yeah, we think about like wireframing the visual aspects of an application, right? We don't really think about wireframing or, modeling the data store, but it's just as important, if not more so. So yeah, that's a really good point.
How about Alejandra?
I'm still having a lot of trouble doing the connections because I felt like I was repeating material over and over, but that's like normal in a database. I'm starting to realize. But my biggest takeaway, I guess, was that a database is just made of objects that have information about a certain thing that is relevant to that thing. That's okay. And popcorn to Audrey.
So, my feelings are just a bit different only because of my understanding of it before we got started. So, to preface what that means for me is just that, like, I study sociology and my interest was this kind of database kind of thing. And so I wasn't good at it, but I had a lot of interest and enjoyed it. So when we got to this, I got really excited and I understood a little bit of it just because it was something that I already walked in with some kind of baseline knowledge to help me feel a little bit more comfortable. And I think that helped me at least going through the lesson. And so when going through it, I think it was interesting to see a non-SQL way of making a database, because I was always trained to do it with relations. Not that I never thought you couldn't do it. I was just always advised and taught and trained to don't do it. So to see it in a different perspective and understand the usability of it as far as scaling up and thinking about that example of Facebook and knowing Facebook and seeing what it has done versus where it is now and seeing how that could be a very great example of scalability, starting from non and making it relationshipable and all that kind of difference and change. It's kind of really exciting to me. And I thought it was really interesting to see that and understand that. And even going through the homework, I was thinking the same exact thing happened to me, where I start off with like one or two things, and then I'd be like, okay, and then I get down, and then when I started thinking about relationships, that's when it really started showing up all these new things where I'm like, well, if I'm doing music, then this is actually relationship to that, and that's really this, and well, I should add that in there. And I had to keep going backwards, and I literally had to keep going over. I couldn't even get everything on the page because every app had something new that came into my mind where I was like, well, what about this? And you have to add that. And that's actually also a relationship rule, and that's something you should actually add. And it made me think about even when Colin was saying that you will build something and then you will be like, and I forgot that. So I had that happen a lot. And that was more my feelings. It was just, okay, this is really kind of cool and interesting to think about database in a non-organized way, because again, for me, everything was always organized. It was always like, this belongs here. That's how it goes. And it's easy to follow that, but it really is, again, for me, really interesting and really fun to be like, let your mind run free, which probably is something I won't do often, because when I do that, I think I get caught in that rabbit hole where I'm just like, I'm not remembering to actually start the code because I'm too much fun with what the ideas can be. And I know I did that especially when I was building Connect 4. So I think I might stick to structure just because I need it.
Okay.
Just because I need it. But it is fun and it is interesting. And I think it's so cool to think about, again, how you can approach something differently.
Cool. Yeah, thanks for those thoughts. Do you want to popcorn it, please?
I do, to Kieran.
So, my big takeaway is, I don't know, so it's interesting, I think. I think it's also a headache. And I still got a few things to learn or figure out. Like, I thought it was, you said relational versus non-relational. I'm not sure I get that. So the thing that got me doing yesterday's homework was there's I guess if you're to use the parent, there's like parent, various parents can have various children, and then those children can also have various parents, and that's kind of where the headache comes in. And there's a lot of repetition. So I was like, I wonder if I don't want to do the violate the dry rule, but there's a lot of repetition and a lot of the different categories that you can have, and I think I need to also still figure out what SQL versus not SQL is, because
So I was saving this to the end, but before we get to Matt, yeah, thanks for those thoughts. So again, like, all of these words should probably be confusing and foreign to you right now, and that's okay. Databases are complex things, but one of the goals of this course is that we introduce two of everything, right? So we talk about two languages, JavaScript and Ruby, which will start in Unit 4. We also introduce two different full stack frameworks, so the mean stack and then Ruby on Rails. And then we also teach 2 types of databases. So right now we're going to be learning about a NoSQL database. In Unit 4, we're going to be looking at a relational database called Postgres. So one of the reasons that we try to teach 2 things is so eventually, as you get a better understanding of the concepts, you can compare and contrast. You know, right now you guys probably can't decipher, why would I use this tool over this other tool? But hopefully by the end of the course, you'll have a little bit deeper understanding and be able to make some intelligent comparisons. We're not there yet because we're just diving into the first database. But again, if some of these terms, relational versus non-relational, if they're not making sense right now, that's okay. You know, we're dealing with a lot of heady stuff with databases, but we're going to get practice as we go through the rest of the course. And so eventually this stuff will start to congeal for sure. And then finally, Matt, you want to take us home?
Yeah, so the biggest takeaway for me was just how important the data modeling first step is, you know, examining your entities and how you need to, you know, truly sit down and think about how you want the app to play out. Because as I moved into the relationship side of it, and I decided, you know, I made this decision, but I want to go back and reverse it or do something different, just how costly that was. Because then I would, at least for last night's homework, I would have to go back through the relationship, change everything, go back through the JavaScript objects and the data type and change everything, then go back to the entity and change everything. And it occurred to me, you know, it was very time consuming just to do it for the homework, but as we're building applications, you know, into the future, after spending days, weeks, and months on it, just how costly that could be to make those larger changes. Not to say that everything should be perfect from the beginning, but it definitely is helpful to try and think through everything at that first stage.
Yeah, I would say that's true of anything with development, right? I mean, you know, measure twice, cut once. I don't want to bore you guys with my painting my accent wall example, but the best practice would have been for me to tape the thing up, which is painful. But had I taped up all of the corners and my windows in the first place, in the long run, I would have saved myself like painting on the ceiling and on the actual windows. So I had to tape up eventually. But hopefully that's, you know, wireframing the visual aspects of your app, creating entity diagrams for your data. Like the more prior planning, the better. That being said, Matt, I think you made a good point. Now, as you scale up, you can't always foresee your data needs in the future. So you're always going to have to update and change your database schema and things like that. And that's okay. I mean, you're always going to have to do that, and that gets easier. But there's a difference between scaling up for unforeseen things versus like not doing the planning, you know, initially. So yeah, thanks for sharing, you guys. I just wanted to kind of get your thoughts before we hop into today's coverage. Let me give you an overview of today. So today we're going to be using a NPM library called Mongoose. Mongoose is a tool written in JavaScript that makes dealing with a Mongo database much easier. So I compare it to, let's say that Mongo is the engine in your car. What Mongoose does, Mongoose is all of the abstractions. So Mongoose could be like the speedometer, Mongoose could be the gas pedal and the brakes. It provides a layer so we don't have to go into the motor itself or the engine itself. We have this tool called Mongoose that is going to do all that heavy lifting, that translation for us. Another way to think about what we're doing today is if you think about the Mongo database, does anyone know how to drive a stick shift? So show of hands if you learned how to drive a stick shift before an automatic. So who learned to drive an automatic first? Okay, perfect. So that's what we're doing today. So think of MongoDB as the stick shift. Today we're going to be using Mongoose, which is like an automatic. Now, we don't have to know how to drive a stick to be able to drive a car. And so we're going to try to give you guys some exercises to get a little bit more practice with going into Mongo itself, but we don't have to have that knowledge for the purposes of this course. And most of the time out in the real world, you're going to be using these tools anyway. So while it's good to know how to get under the hood and tinker and change your belts and change the oil, you need to know enough to get by. but there's a lot of tools that are going to do that for us. One of them being Mongoose. So this morning, we're going to go through Mongoose and how to query our database with CRUD actions. So we're going to learn how to create, read, update, and delete with Mongoose queries. This afternoon, we're going to build a second app that's going to take what we learned this morning, but we're going to put it into an Express application. So then we're going to be able to send data to our browser. Then tomorrow, once we have those 2 steps completed, tomorrow we're going to learn how to put views on top of that data that we're retrieving from our database. So we're doing this in 3 very distinct steps. So that's where we're headed. So today we're going to build 2 applications. Let's get started. If you guys want to click, if you want to follow along. So this morning and this afternoon, we're going to be building 2 apps together. So I'm going to do a step and give you guys a chance to repeat those steps on your own. And I'll be sharing my screen a lot. But I want to just briefly, there's like kind of an instruction manual. There's some like text at the top of the lesson. And I don't want to bore you guys with all of it. I'm just going to hit a couple of highlights as we get started. So just to recap, what is a NoSQL database? A NoSQL database is any database that is non-relational. It's kind of a large umbrella. Again, if these terms don't completely make sense, that's okay. I think they'll make sense over time. So this means that there are no explicit one-to-one, one-to-many, and many-to-many relationships. That being said, and I think Mike asked this question, you can emulate those relationships in a non-relational database. But NoSQL databases, their big advantage is that you don't have to design your data that way. That may be a little confusing, but today we're going to be using, storing our data the way that NoSQL intends, and it makes it super fast. And I think it'll make conceptual sense to you guys when we get into it. Let me scroll down a little bit. So some of this may be a recap from yesterday, but why are we using NoSQL or MongoDB instead of a relational database? Well, there's a couple of reasons. One, like I mentioned earlier, is very flexible. So if you just need to get an MVP out the door, Mongo and NoSQL databases, may be a good option. Just let me get this thing deployed. I just need some basic data store that isn't gonna, constrict me with a lot of rules. So that may be an option, a reason to use NoSQL database. The other big reason is that Mongo is the M in the mean stack. So since the Mongo database and Mongoose, which we're going to use today, is all written in JavaScript, so you only need to know one language as you build your full stack application. So that's a really great advantage. So maybe you sacrifice some performance or something for using a Mongo database, but the trade-off is that you only need to know one language. Let's see. Let me show you guys this chart, this little graph of some of the terms we're going to use. Again, some of this may be a recap from yesterday. Here's some Mongo and Mongoose database terms and concepts. So we have a database. So each application that we build is going to have its own database. Inside of a database, you have collections. So let's say that we're building an app. Today, we're going to build an app where a student has many projects. So maybe we would have a student collection. Think of it as a big filing cabinet that contains all of the student data. And then maybe we have a filing cabinet for projects that would contain all the project data. And we refer to those as collections. A collection would hold instances of some model or some constructor function, if you will. So inside collections, each individual instance of something, so each individual user or student would be considered a document. So that's like an individual record of something in our database. And then finally, inside of the document, a document you can think of as an object. And when we think of objects, we think of key value pairs. So in the context of Mongo, we're just going to refer to those key value pairs as a field. So instead of a key with the value, it's going to be considered a field with the value. It's the same thing as a key value pair. It's just like the semantics of it. So I just wanted to make you guys aware of that. Sorry, Kieran, I just muted you. Let me show you what a MongoDB document looks like. And Colin may have showed you guys this yesterday. This is what all of our data is going to look like today and going forward. But this would be considered a Mongo document, and it looks like a fancy object literal, essentially. But what Mongo gives us is it creates that underscore ID field, and that's usually like the first field listed. This object ID, it looks like a crazy series of numbers and letters and such, but there's actually a method to that madness. We want Mongo to create that object ID because that's a very unique ID. If you look it up, some of that ID refers to a timestamp, maybe the version of this object. So if you like update the first name or last name, it contains some of that information. But that's how we make sure that no two objects have the same object ID. As you can probably guess, it's hard to like repeat yourself when Mongo is creating that crazy hash, crazy object ID. And then this object would have like a name field. Name actually contains an object with a first and a last name, birth, death, contributions. So contributions would be an array of strings. So, and then views is an integer or a number. So again, to demonstrate with our fields, the value can be any JavaScript data type. It can be an object, an array, a number, a string. It's pretty flexible. Pretty much anything we can do in JavaScript, we can do within this database. Audrey says, that's your birthday. Really? June 23rd, crazy.
I'll be expecting gifts now. Thank you, guys.
I will put something in the party time channel for you. So before we hop into Mongoose, just let me talk about this one screenshot, and then we're going to get into our code along. So again, we're using a tool today called Mongoose. So Mongoose is just going to do some translations for us. So we don't have to go directly into our Mongo database to do stuff, to get records, to write records, to update records and delete records. Mongoose is kind of a layer of abstraction that's going to do this stuff for us, and it's going to make our lives a lot easier. Mongoose is considered an ODM, and ODM stands for Object Data Mapping. So Mongoose can wrap this data, wrap our queries, and kind of convert it into an object that we can do more things with. I know that doesn't mean much right now, but we're going to see how this gives us, it gives us a lot more methods and abilities than just using the Mongo database by itself can provide. This is an example of what's called a schema in Mongoose. And this is what we're going to be building today. So in this example, we're creating a variable called cat, and cat is capitalized. And you can think of capital C cat as kind of a constructor function like we talked about on Tuesday. So this cat is actually an instance of a mongoose.model. So a mongoose.model you can think of as a fancy constructor function. A model is something that we're going to create new instances of a given thing out of. So we could use this capital C cat to create new instances of a cat, Garfield or Heathcliff. That's really where it ends and begins with my cat knowledge. I can't think of any other cats. Catwoman, Batman, I don't know. So this is kind of, so the syntax hopefully is familiar because this is what we're going to be building today. So just wanted you guys to get a taste. Okay, so let's actually get into the code along. So I'm going to start my screen share. Any questions before we get started? I think you guys will have questions as we go through the lessons today. So feel free to ask me on mic or put them into Slack and we'll address them. So I'm going to share my screen. I'm going to walk through these 6 steps and then give you guys an opportunity to create this app yourself. We're just going to get this app set up instead of giving you guys starter code. So just hang tight for a few minutes and then I'll give you guys some time to set this up yourself. So I'm going to start my screen share here. Okay, so the first thing I'm going to do is create a new project folder. I want you guys, you can just dump this into your student labs folder. I'm going to create my version of this app in an instructor examples folder in the week 7, day 4 directory on GitHub, because I'll push up my finished code at the end of the lesson. But I want you guys to put yours in the student labs, obviously. So again, just hang tight for a little bit so I can walk through these steps. So we're going to call this just Mongoose intro lesson. Pretty fancy. And then let's make sure to CD into that. And then we talked about the first step when we're using Node is to npm init. Does anyone remember what this -y does? When we npm init -y, what is that going to do for us?
It just auto fills out all those options.
Yeah, it's just going to like accept the defaults. It's like we push enter for all of those like 8 steps. So it creates this package.json. The next thing I'm going to do, because we're going to need a database directory, so I want you guys to create a DB directory, and then create the following files. So we'll create a server.js, which is going to be, you know, all of the node information. We're going to create a schema file. So the schema is going to be the specific criteria, what we want each student to look like. We want them each to have like a first name, a last name, email, etc. And then a seeds file. So a seeds file is a way that we can quickly add data to our database. And we're going to walk through, just so we don't have to hard code a couple of students to play around with. We're going to play around with a seeds file, and then in one fell swoop, we can upload some data to our database, some dummy data, if you will. And then just let me open this up in Atom so you guys can see what it looks like. Drag it down here. Cool. So this is the folder structure, and there's a screenshot there in Slack as well. So we just need a database folder with schema and seeds, your package.json, obviously, and then server.js. So let's stop right there and give you guys a chance to get up to speed there. So go ahead and walk through those steps and set up your application. Again, be sure to set yours up in your student labs folder. And then give me a thumbs up in Slack when you successfully set that up. I'll stop my screen share for the moment. All right. Cool. We have 6 thumbs ups, 7 thumbs ups, just waiting on one more, then we'll move forward. All right, all 8, nice. Okay, so let's go to the next section. So what we want to do next is we actually want to npm install this Mongoose module. And I want to give you guys a heads up. So everything we're doing for this morning lesson before lunch, we're not going to be putting any code into our server.js. We're going to keep this as simple as possible. We're actually, I don't anticipate we'll even need to start up a node server. We're just going to write some JavaScript in our schema.js file to see how these queries work. So just a heads up, you shouldn't have to touch your server.js file. It's just going to be empty throughout the morning. So step 1, let's install Mongoose. So since it's an npm module, we'll do an npm install and let that load up. And then going to type out some code. I would encourage you guys to type this stuff out and we'll talk about it. So give me just a minute or two to walk through this, and then I'll give you guys an opportunity to type it up yourself. So in our db.schema, the first thing we need to do, just like we would do with any other npm module, right, is we need to require Mongoose. Make this a little bit bigger for you guys. Cool, so we're gonna pull in the Mongoose module. And then one of the methods that Mongoose gives us is a connect method. And all that this connect method does is we're going to tell Mongoose which Mongo database that we want to write to. So remember that every app we build is going to have its own individual database. So we need to put that here. And so what you can do is do MongoDB. So when you
a question. Are we following along, or are you showing us something?
I'm showing you, so just hold tight for a minute or two, and then I'll give you guys a chance to type through it. So I just want you guys to pay attention so we can walk through why we're typing this stuff, and then if you have any questions. So I would politely ask you guys to hold tight for a moment. So what this line is saying, this mongoose.connect, is I want to write all the information for this app inside a database in my Mongo database engine called students. Now, the beautiful part about MongoDB is that we don't even have to create this database out of the box. Mongo is going to create this database for us the first time we try to write to it. Now, with a relational database, you have to like create the empty database first, right? You have to like create an empty filing cabinet before you even start saving stuff. But Mongo is really flexible, and it's going to create that. We don't even have to create that filing cabinet, if you will, initially. It's going to do that for us the first time we try to create something. I'm not even sharing my screen. I apologize, guys. Thank you. My bad. Here we go. Sorry, friends. That's no fun. So can you guys see my Atom and my terminal now? Okay, cool. So all that I did is I installed Mongoose, npm install, and then I added these 2 lines to my schema.js because this is really where we're going to do most of our code today. Cool. Yeah, so next, I'm going to add this line of code, mongoose.promise equals global promise. Now, you can read the comment in the screenshot. Let me put in the next screenshot, by the way. So the only reason that we're doing this, we're going to be using Mongoose has some built-in promises we're going to use. But I'm putting in this line of code. You don't need to worry about it, but you're going to get a warning in terminal, like a depreciation warning, saying that you need to tell this app, you need to specify what promise library you want to use. And there's a lot of third-party promise libraries that we can't use. But again, just so we don't have to deal with that depreciation warning in our app, we're putting in this line of code. All this line of code is doing is it's telling Mongoose to use the ECMAScript 6 default promise library. Otherwise, it's going to give you a message in the terminal that says, hey, dude, tell me which promise library you want to use. So for now, that's going to be fine. We'll use this global.promise. I'm going to create a var db and I'm going to make this equal to Mongoose connection. Now this is kind of optional. I'm just literally, I'm going to have to write mongoose.connection 3 times. So I'm just assigning it to a variable called db just to be a little bit more dry. But that's kind of optional for you. If you want to type this out each time, that's fine. The first thing I'm going to do is I need to write code that will connect to the database. And before I do that, I want to tell Mongoose what to do in case it encounters an error. So I'm calling essentially this is mongoose.connection, right? Because it's DB. So on connect, let's put in a callback for what happens if it gets an error type of a condition. So I'm just gonna, this is pretty boilerplate. It's just from their documentation. So I'm just gonna console log any errors that we get. Again, nothing too fancy. It's literally from the documentation. The next thing I'm gonna do is call the open method. So what happens when I open the database? We're gonna keep this pretty simple. Actually, that should be once, excuse me. And then what do we wanna do when an open condition is met with our Mongo database? We're gonna keep this pretty simple as well. We're just gonna console log a message that says, hey, you've connected to the database, just so we know. So database has been connected, just kind of giving ourselves a heads up there. And then the last thing we're gonna do is I'm gonna do a database.close. So it's really good practice once you send a query or once you access the database, it's a good idea to close that database connection. So each time we run this schema file, because we're gonna add a lot more code in here, every time that we run it, after it's processed all of our queries, it's gonna cut the connection. So it's just kind of a proper way to do it. We don't want to leave that connection open to our database because, just better safe than sorry. So that db.close is just going to close that connection after we do whatever we need to do to it. So let me save that. And then this last step, I'm going to run, this is how we're going to be running our code for most of the morning. I'm just going to run that file using Node. Node, run my schema.js file, which is in my database. And so this is what we should get. I'll change the spelling there. So we don't have any Mongoose, query in here yet, any queries. So all we want to see is that database has been connected. And then since we have this close method, notice that it takes me back to the command line prompt. Otherwise, we would see database has been connected and it would just like stay there. So we want to be very polite and close our database when we're done using it. So let's stop right there. I'll stop my screen share and then have you guys walk through those steps.
Also, to add on one thing, you have to have mongod on in one of your terminals in order to connect to your database.
Yeah, so the way that you guys set up Mongo yesterday, you need to make sure that you run mongod, which will actually like start up the engine. So you may want to have that. My engine's already running, so that's why I didn't put that step in here, but that's a really good point. Otherwise, you're going to get that some sort of error saying it can't, it can't connect. So you probably want to have 2 terminal tabs open, one for the command line and then one with mongod. I'll put that into Slack. This afternoon, we're going to have about 4 tabs open, so going to kick it up a notch. And then give me a thumbs up in Slack when you guys finish up that code. This code is pretty standard. Again, it's from the documentation. There's more that we could add here, but this is kind of like the boilerplate to get our Mongoose up and running and connected to a database. So we're trying to take the path of least resistance this morning. So Karen, you're getting a throw error. Do you want to share your screen? We'll take a look. I would imagine that this is probably a syntax thing, misspelling, or maybe a semicolon out of place or something.
Yeah, I think so too. That's what my throw errors have been so far. So,
and throw errors, they're a nuisance, but they're usually pretty good about pointing out exactly what it doesn't like. So it's really easy to find that needle in the haystack most of the time. But yeah, let's take a look.
Okay. So it was the throw error was let's see.
So you misspelled on line 2. That's MongoDB.
Ah, that's what it said.
And if you look at the error message, it literally told you what the issue was, right?
Yes.
I think it even tells you. Cool.
DB.
Yeah. Yeah, that's a really good error message, actually. Invalid MongoDB URI must begin with MongoDB, so that's helpful. Let's see where it's blowing up now. So on line 15, so close, we need to invoke that method. So let's put parentheses on that on line 15.
Parentheses.
No, so Kieran, we need to invoke that method, which means adding parentheses to the end of the close method. So dot close parentheses. So we're invoking that method. Cool.
There we go.
There you go. Nice. Okie dokie. Let's see how many thumbs ups we have. 4 thumbs ups. So just a few more peeps. Six thumbs ups. Okay. So you let me know if you're having any errors or my terminal is stuck. Network is waiting for connections. Okay. Audrey, do you want to share your screen? We'll take a peek.
Yeah, I just figured it was just being slow. I didn't think it was like,
Sure. Okay.
But yeah, so.
Okay. So, so it looks like you tried to run that command in your mongod window. So we don't want to do that. So, scroll.
I did this afterwards. It stuck like this for a minute. Still, I thought that I was supposed to do that afterwards, but I was stuck like that for a long time beforehand.
Okay. Give me a Control C. So let's stop that process. And then run mongod again. Do you have, I'm trying to read your error stack. Do you have mongod working, running in some other, like a homework window or something? Is this the only place that it's running?
Yeah, because even beforehand, I tried running
cool.
thing and I had an error to check
Okay, so let's go into the other tab and run that command node space db/schema. Schema.js. There you go. Yeah, cool. So it's working. Mongod will sometimes print out some messages like if something's been depreciated or if it would prefer that you write your code some other way. So that's a lot of garbage, but it's fine. You are connected. If you look at that the last line, it says one connection now open. So you're good to go. All right. So how many thumbs ups do we have? Okay. So I think we're missing one thumbs up. So go ahead and give me one. Oh, I guess Audrey, that may be you. All right. So let's move forward. Let's talk about Mongoose schema and models. So NoSQL databases, Mongo in particular, doesn't require a schema. So that's why it's very forgiving. It's just an empty, ball of clay, if you will, and you can just dump whatever you want in there. However, it does make sense that we create some sort of schema or some sort of blueprint for what we want our data to look like. So if I'm going to be creating new users or students or whatever, it makes sense in the long run to create some criteria for what I want a student to look like. It's essentially like building a constructor function, right? So I want each student to maybe have a name, an email, location, things like that. So although Mongo doesn't require a schema, technically, we do want to use one because Mongoose allows us to create some structure, which is really important and another benefit of why we're using Mongoose in the first place. So in the screenshot, this is an example of a basic Mongoose schema. And you can think of a schema as a blueprint for whatever objects we want to create. This is a very simple example of what a student schema would look like. The first thing that we're doing, I'll go ahead and share my screen and walk through this and then give you guys a second to recreate it. And remember, we're going to be putting all this code in our schema.js. So this file is going to look a little janky, but it's okay. This afternoon, we'll be doing this in a more like separation of concerns way. So I'm just going to add this code down below what we've already added. The first thing I need to do is I'm going to create a var schema, and I'm going to attach the schema. So this capital S schema is kind of a constructor function for a schema that Mongoose gives us. And I'm attaching this, or I'm assigning it to a variable called schema. Again, this is just because I'm going to be reusing this a couple of times. So if I have like multiple objects or models that I want to create, I'm going to be typing mongoose.schema, several times. So this is just kind of a convenience and a dry thing. So I'm attaching mongoose.schema to a variable called schema so I can reuse it. The next thing I want to do is create a variable that will contain the structure of what I want a student to look like. And so for this morning's example, we're going to create a student schema. And there's our good friend new. So that should tip you off that this is just a fancy constructor function underneath the hood. Just like we did on Tuesday. It's the exact same principle. So we're creating a new instance of a Mongoose schema specifically for a student. So this is what I want a student constructor function to look like, essentially. We'll keep this pretty simple. Let's just add for this morning, we'll give it a name. And when you construct these schemas, you need to tell the database what data type to expect. And this is really good if you're going to do validations or something. So for example, if I have a telephone number field, maybe I want to make sure that it's a number field and not a string field because I want to save digits to the database, right? Not some goofy string. So that's one advantage to being very explicit with the type of data that this should expect. And then we'll just do an age, ain't nothing but a number. And remember, or if you notice, these data types are capitalized, right? Because this is a capital S string, capital N number. So that's going to create our constructor schema.
I have a question.
Sure.
When you're assigning the type of data it's going to be, you can only assign one type of data. You wouldn't never want to do more than one type of data because, for instance, again, if you were doing a number, numbers sometimes have dashes and parentheses. They may not recognize that. So in some cases it might be easier to use as a string. But would you just say a rule of thumb is probably best to just use the one instead of trying to get fancy and use more than one?
Yeah, you can only use one data type for each field. Now you can change the data type. Mongo is really forgiving. So let's say that right now age is a number. Maybe tomorrow I want to change that to a data type of string. It just means that when Mongo saves it to the database, it's going to save it as a number or save it as a string data type. It's pretty flexible. And actually, I would imagine that if you submitted a form with age, for example, and if you put 20 and then like a plus sign, actually that would probably error out. But I would imagine that Mongo would just go ahead and save it to the database because it's very forgiving. It's just going to save whatever information you give it. However, if you want to be very proper with, again, form validations, if you want to make sure that an email field has an @ symbol, things like that, part of the advantage of using a schema is that you're creating a structure for your models. And so part of that paradigm is that you're actually declaring the data type that Mongo should expect under the hood. But you could go back and change age to a string or whatever, but you couldn't have like number and string for age, right? You have to choose one or the other. The last line of code I'm going to put here is, and then I'm going to show you guys kind of a drawing and then let you guys write this code yourself. So keep in mind that a schema you can think of as a blueprint, and a model is kind of the ideal version of that blueprint. So a schema is a blueprint that compiles into a model. And a model is what we're actually going to be creating new instances of. So at the end of the day, the model is like the big thing that we're going to create new users out of or new students out of. It's considered a model. And so MVC, we talk about the MVC framework. This is the model of an MVC framework. So I'm going to just call this student model. And I'm going to make my student model Mongoose. Mongoose has a model method, and it knows that it's going to take some sort of schema and compile it into this reusable thing called a model. And this takes two arguments. The first argument is going to be, where in the database do you want to save new instances of this student? So we're going to have a collection in our database that's only going to contain instances of students. I know it's a little wonky because this is database collections are plural. So there's actually a students collection in our database because it contains multiple students. But the Mongoose convention is that the first argument is a string and it's generally capitalized and it's singular. There's some stuff that goes on under the hood, but essentially this is referring to where in my database do you want me to store this, which collection? And then the second argument is the actual schema that you want Mongoose to compile into a model. And so that's the second one here. So we want to create a student model from this blueprint called student schema. And then let me paste this little diagram. I don't know if this will be helpful or not. This is a little bit down the page, but maybe this will help illustrate this idea. So if you look at this image, here on the left-hand side, you have the application, and on the right-hand side, you have the database or the data store. So the way that this works, the schemas and models and such, is if you're looking on the left there, the application side, we start with the schema. And again, I don't mean to be redundant, but a schema you can consider a blueprint of what we want a given model to look like. And then you see in blue there, it says schema compiles into a model. And so down below that, we have a model. And so a model is like a fancy constructor function. You can think of it that way. And then from a model, we can create a single instance or we can create an array of instances. A model essentially tells our application what that student data looks like in our database. So if we try to pull a last name from student, our application knows that a last name doesn't exist because it doesn't exist in the model. And we have a name field and we have an age field, but so far we haven't created like an email field or a phone number field. So part of the model is that we can create new instances of something, and it also lets the application know what's available to us in the database, particularly the schema. So remember, the schema is a blueprint. So our application can quickly say, oh yeah, I can't query for last name because I don't have that field available on a student. So it's another way to kind of check your data. And that's what Mongoose uses these models for. And then one last piece of this, and then we'll pause for you guys to build it. I mentioned this term ODM earlier. ODM stands for Object Document Mapper. It maps objects to documents. So Mongoose gives us the ability to do CRUD operations, which is what we're building this morning, on a MongoDB database using JavaScript objects as our model objects. That's a lot of jargon, but we're going to walk through it today. So a model object is an object whose primary concern is to hold data and represent an instance of a domain model, if you will. So domain models, that's what you guys talked about yesterday when you talked about data modeling or wireframing your data. A model is a representation of that data wireframe that you guys went over yesterday. And then quickly, for example, if we were developing an application for Delta, we might have domain models for airports, for the various flights, for the various passengers on those flights, for the luggage that belongs to the passengers that need to get on the particular specific flight. And then instances of an airport domain model might be ATL, LAX, Orlando, Dallas, Fort Worth, etc. I think that's pretty much what you guys covered yesterday. But this is how that schema and model kind of are intertwined. So maybe that graphic's helpful. But let's put a pin in it right there and have you guys create those few lines of code in your schema.js file. And then I'm happy to answer any questions. So go ahead and add that code to your schema.js and give me a thumbs up when you are done with that. And then we'll move, we're almost to actually writing these queries, just a few more setup steps, and then we'll be good to go. All right, 7 thumbs ups. Just need one more. We're about 2 minutes away. All right, cool. So we have 3 thumbs ups. Yep, go ahead.
Sorry, I just wanted to make sure that I'm putting it in the right place. This is going to be in between our connection because this is what it's reading. It's not going to, so between our open and our close is not like below all the stuff we just wrote.
I'm putting all this below. This file will run properly either way. But yeah, I'm just putting it below just to keep things separate. If you want to put it up there, that's fine too. I was just trying to put some organization, so if you guys need code, you can kind of see where it reads. But like I said, I'm just going to tell you guys, this schema.js file is going to be a little sloppy. We're just going to put everything in one file for this morning. This afternoon, we're going to break it out. But yeah, you can pretty much put it wherever in this schema.js file. If you do get an error, just ping me and we'll, straighten it out. But I don't think you should have any conflicts. Cool. So we're almost there, you guys. Thanks for hanging in there. Let's talk about embedded documents. So embedded documents is really the great advantage and benefit to using a NoSQL database, and Mongo in particular, because relational databases do not have this ability. So if you use Mongo the way it's intended, embedding documents within other documents, you can really get the best performance of it. And so that's why we're going to tackle Mongo using it the way that it's intended. So let's add another model to our schema.js because we want to have students, and a student has many projects, right? Because you guys are going to have 5, 6, 7 projects throughout the course. So that's what we're going to model in this application. So we're going to be adding a schema for project, since I want to create an app that tracks students and projects. And this is similar to a one-to-many relationship in a relational database. So we're going to talk about that in Unit 4, but it's the idea that one thing has many of something else. So a student can have many projects, and a project would belong to one student. So that's kind of how you would think about it. And this is what it's going to look like. So let me slap this code in here, and then we'll take a second for you guys to do it. I'm going to create a project schema. Let me share my screen. And it's pretty similar to the student schema. We're keeping this pretty bare bones. Here we go. So down here below, well, actually, I'm going to put it above. I'm going to create a project schema. And again, anytime we create a new schema, we're essentially calling mongoose.schema. And I just attached it, I just assigned it to a variable to be a little bit more dry. And our projects, we're going to keep them pretty simple. Let's just give them a title of a string data type, and then let's give them a unit. I'd probably use a number, but let's just be consistent with the lesson. We'll just make this a string. So I don't know, unit 1, 2, 3, 4. Actually, when we seed our database, we're going to be doing like an Angular unit or a Rails unit or a Express unit. So that's why this is a string data type right now. Now, the idea is that we're going to create student documents. Instead of having separate documents for a project, we're going to actually save those projects directly in the student document. So if you think about a filing cabinet with file folders for each student, instead of putting your projects in like a separate projects filing cabinet, so there's 2 filing cabinets, why don't we put your projects in your students folder? So it's really easy to find. So instead of looking up, looking in 2 filing cabinets, we only have to look in 1. So when we pull up Alan in the database with a query, all of your projects are right there at our disposal. This is what makes Mongo super fast if you do this correctly, because your database doesn't have to work as hard to find information. So we created our project schema. And down here on student schema, let's add a field of projects. And this projects field is going to be an array of, projects, whatever 6, 7, 8 that you guys have. But specifically, we want each project to adhere to this project schema structure. So we want each project to look similar. We want each project to have a title and a unit. So this is how we set that up. The field is projects, plural, because you're going to have an array. Even if it contains one project, it's still going to be an array of potentially, multiple projects. And then we pass in the schema for which we want each project to be modeled after. So we pass in project schema here. And then lastly, down here at the bottom, so we can create our queries and such, we're going to also create a project model so that we can have a project model to create new projects and also a student model. And then here you can pass in project. So we're not going to be using a separate project database, we're not going to be using a separate project collection or filing cabinet. We're going to keep everything in our students filing cabinet. However, Mongoose convention dictates that we still set it up this way. So maybe in the future we do want a projects collection, at least we already have it set up. So there we go. The one caveat when you guys put this code in, this needs to be in this particular order. So since we're creating embedded projects within student, we just need to make sure that when this file is run, we need to make sure that it loads up the project model before the student model. Because remember, the student model is going to embed projects. So in this case, just make sure that your project is above the student. Otherwise, when you run the code, Mongoose is going to barf at you and say, I don't know what a project is and such. So we just need to make sure that it's in that order. Okay, cool. We're almost there. So go ahead. We'll do a little bit of a you-do. So add the code for your project schema. I'll stop my screen share. And then give me a thumbs up when you have that set up. And then we're going to create our first query out of create. The C in CRUD. And also, as we're going through today's coverage, I would encourage you, if you want to write comments. So I put comments in the lesson, although I'm not typing up comments in real time. But it may be a good idea as you're adding the code, just to reinforce stuff. If you want to, take some notes in the comments, that's probably a good way to kind of reinforce this stuff. All right, 6 thumbs ups. All right, got 8 thumbs ups. Throw this screenshot into Slack. So let's create our first Mongoose query to create a student. And I think I've exceeded my image upload to Imgur bandwidth. So we use a tool called Mac2 Imager. I don't know if you guys have used it, but when you do a screenshot, it automatically pushes it up to Imager, and you can paste it. However, as that app has grown, as it's become more popular, there's actually a bandwidth on whoever made the app on how many images can be uploaded per day. I don't know if it's like 5,000 or something. So I'm not uploading 5,000 images. It's everyone that's using that app. So sometimes like you'll reach a bandwidth, and I don't guess they want to pay for it. It looks like it uploaded though. Okay, cool. But occasionally we'll reach the bandwidth limit, and it won't let you like upload any more images for that 24-hour period. That's always good times. Okay, so let's create a Mongoose query to create students and projects. So let me share my screen, and let's create the C in CRUD. And let's see what that looks like with a Mongoose query. So we're going to add this code below all of the code that we've created thus far, because we need to load up all of the schema and model info so that Mongoose knows what a new student should look like, that kind of thing. So let me put Mongoose queries start here. Okay, so the first thing we're going to do is create. So let's create a new student. And we're going to do this in 2 steps. We're going to instantiate a new empty student, and then we're going to save that student to the database once we've added name and age to him or her. So this is going to take a constructor, and this constructor is actually whatever we called our model. So this is going to be a new instance of a student model, like so. And so inside the student model, we want to pass in an object containing the fields and values for this new instance of a student. So for this one, let's do a name of Chuck. I don't know why. And then an age of 30. So that's going to create a new instance of Chuck assigned to a variable called Chuck. So that's step 1. The next step is that we want to save it. And so this is how we would do that in Mongoose. So we're going to call the .save method. Save takes a callback function that will do error handling, and then if we want anything done on a successful save. Now we're going to take a look at using Mongoose promises this afternoon. It's not very different from just passing in a callback function, but this would be considered a callback function for our save method. So it's going to take 2 arguments. That should be student. The first one is the error, if there is an error. The second one is whatever you want to call whatever you're saving. So, to be consistent in our naming, I'm going to call this Chuck, I'm just going to call him student. So I'll pass in a student variable. And this variable contains whatever you're saving, okay? That's what that parameter represents. Cool, so down in here, and this is pretty boilerplate. It's a little, you actually don't even have to write an error handler if you don't want to. I'm just doing it because this is what the docs recommend, and it's good practice to have an error handler for sure. But let's just do, if there's an error, then let's console log the error. Else, let's console log the student. So for this morning, we're not going to go into Mongo to actually, we're not going into the database itself to confirm that the student's been created. We also don't have any views yet to confirm that the student has been created. So for this morning, we're just going to console log to confirm that this new student has been saved to the database. So this is what our first create query is going to look like. Let me run this code, and let's see if this is working all right. So I'm going to run node db schema.js. We get our database has been connected method, and then it returns that new student object. And I know that it is a new student object because it has an ID assigned to it. So remember that Mongoose, well, technically Mongo, through the power of Mongoose, is going to go ahead and create that underscore ID field, and those are always unique. So it's really important that we don't touch that. You can change the ID, you can make it whatever you wanted, but we're just going to let Mongo handle that. So it created a new instance of a student, and here he is, name, age, this underscore V. So Mongo has some built-in goodness that tracks when you change an array. So let's say that we have an array of 10 projects and we delete one. Well, Mongo, part of the beauty of why it's so fast is that it indexes its documents. So it knows what that array of projects looks like. It knows that it has 10 projects. Now, if we delete one of those projects, the order of that array is going to change. So this underscore V is just some stuff underneath the hood of Mongo. So Mongo keeps track of every time like an array or an object is updated within the record. It's just some internal indexing magic. We don't need to worry about that. Then we have the ID, and then we have the empty projects field. We haven't created any projects. We'll do that later. But yeah, this is a successful new and save. So let's go ahead and pause for a second and let you guys, well, let me show you the other way to do this, and then we'll take a quick pause. So there's two ways to persist things to a database. You can use new and save, which are 2 steps. You can also use the .create method. Now, why would we want to have 2 different ways to save something to the database? Well, there's some good reasons for that. Either one is fine for what we're doing today, but just so you're aware of why there's 2 different methods. So let me show you how to do this with the .create. It's a little bit less code, but maybe you want to separate it out into a new and a save. And some reasons for that, if you take a look at these bullet points, maybe we want to instantiate new instances of something for test purposes, but not actually save those instances to a database. So what I mean by that is either you can do it manually, or there's also a lot of third-party libraries when you're testing your code. They may just write some dummy data, some dummy students. It may create like 1,000 different varieties of students with different ages and names and stuff, just for testing purposes. Now, we actually don't want to save those 1,000 test dummies to our database, right? We don't want to sully our production database. We just want to test out, make sure everything's working the way it should. So maybe we want to create these new instances of students, but we don't really want to write them to the database. We just want to like create them and hold them in memory and test them out. So that would be one reason that we want to have new and save separate. Additionally, the second bullet point, we're going to take a look at this afternoon actually. Maybe we want to add something to that new object. So we created a new Chuck object, a student instance, and then we saved it separately. Maybe in between, if you notice in our record in Mongo, it doesn't have any kind of like timestamp information. So relational databases, Postgres in particular, is really good. Actually, we're going to use a tool similar to Mongoose when we get to Rails that saves a created at and an updated at field. And that's really good information, right? So right now, I don't know when this record was first created, nor if I update it, throughout the weeks or whatever, or today, it's also good information to know the last time this record was touched or updated. So let's say that in between creating this object and saving it to the database, we want to like add some timestamp fields or something. So that may be a reason to separate new and save. And then that last bullet point, just note, this is pretty much what we did here. If you're going to use new and save, you need to assign that new object to a variable. Otherwise, we can't call save on it, right? If I just instantiate a new student model, I don't have access to that new thing. It's just like in the ether. So you need to make sure to save it to a variable. And I'm just going to throw in the code for create. It's right there in that screenshot if you're interested. Actually, I'll let you guys do that. You guys can see that code. It's pretty much the same thing. It's just that .create is going to instantiate a new object and save it all in one command. That's pretty much what it does. Let me stop my screen share and then give you guys a second to play around with your create methods. So go ahead and create a new instance of a student using new plus save, the way that I showed you, and then play around with creating a new student using .create. So let's take, we'll take like 10 minutes for this. Let me stop my screen share. Go ahead and take a break, stretch your legs if you want to, but try to create like 2 students of each type. So 2 students using new and create, new and save, and then 2 students using .create. You can just add it to the schema.js file and then run node db/schema.js to test it out. So go ahead and stretch your legs. We'll meet back at like 12:42 while you guys work on that. All right, so far this morning, we've done a lot of setup to get Mongoose into our app and such, and create a schema, which compiles into a model. We've created a student and a project model. Let's take a look next, and we just created a new student, which is great. Give me a thumbs up if everyone was able to successfully create a student. I should say the word persist. So either you used new plus save, or you just did it using .create. So is everyone cool? Okay, so let's move forward. I mentioned that really the beauty of NoSQL databases and Mongo in particular is this idea of embedded documents. So again, we have students and we have projects. Normally we would have separate filing cabinets for projects and a filing cabinet for students, but it's much quicker for Mongoose and Mongo to find the data we need if we just create new projects and dump it directly into Mike's folder or Sophia's folder. Like, let's just keep the projects with the student. It's much faster to find the information that way. So I'm going to share my screen and let's take a look at what an embedded document would look like. So hold tight for just a minute, and then I'll give you guys a chance to recreate this yourself. I'm going to keep the party rolling down here. I'm going to put this code below the code that we just created. So again, this schema.js, it looks a little janky. I'm just putting all the code, below what we just did. So for this one, let's create a new instance of a student named Anna. This student, we're going to use the student model to instantiate a new student named Anna. So we'll pass in the object with the fields named Anna, age 30. And then let's create a variable containing a new project instance. So let's create a project 1. And for this one, we're going to use the project model. And we'll pass in the object with all the fields. So let's make the title memory game or connect 4, whatever you guys want to do. And then for the unit, we'll just make this the JavaScript unit. Cool. So we've created, make sure you guys can see this. Cool. So we've instantiated a new student and a new project. Now let's merge the two together. Let's embed this project on the Anna document, the Anna object. So remember that Mongoose and Mongo, the beauty of it is that it just is written in JavaScript, so we can use vanilla JavaScript when we write our code. So I'm literally going to push project 1 onto Anna's projects array. So remember that our student schema, every student has an empty array to contain the projects. So we can push onto an array, it's a JavaScript method. So I'm going to push this project onto Anna's project field array. And then the last thing we want to do, we instantiated new project and new student. Now let's save Anna. So I'll call Anna.save. So remember that our save method takes a callback. And to be proper, we want to pass in our error handler or error object if there is one, and then the student that we're saving. And let's do, again, pretty much the boilerplate. I know it's a little like wonky, but if there is an error, we'll console log it. Oops. Else, just console log the student, just return it. Cool. That looks good. And in the lesson, I just like put a little string concatenation. So I'll put that here just to be consistent. So Anna was saved to our DB. Again, we don't have any views, and we aren't going directly into the Mongo database to confirm this. So that's why this morning we're just doing a console log. So I'm going to run node DB schema again, and it's probably going to create another chuck because I didn't comment out that code, but that's okay. So let's run that. And I probably have a typo in here somewhere. Cannot read property push if undefined. Let's make sure I closed everything out correctly. New project model.
I think it's projects.
Yeah.
Yeah, really good catch. So remember, when we add that embedded document, it's going to be plural. Yeah, thanks you guys. Thanks for keeping me honest. So let's run that again. And there we go. So I didn't comment out that chuck code, so now I have like 2 chucks in my database. That's fine. But it did create the Anna document, and it also created that project. So remember, we're not saving project in a different place in the database. We're just going to embed it directly on the student object that that project belongs to. And you can tell that this projects, remember that it's an array data type. So even though it contains one project, it's still an array. And then we have that was saved to our DB message right there. So that's what an embedded document looks like. And so hopefully, I know we haven't gotten to relational databases yet, but this really is one of the great features of using Mongo and why it's so fast if you use it the way it's intended, using embedded documents. So we really, Mongo only has to look for the Anna document, and any other embedded documents are right there at its disposal. So it's super fast. So let's put a timeout right there. Let you guys practice creating an embedded document, and then we'll move forward. So go ahead and create a new student, and then add an embedded document, an embedded project to that student. And then give me a thumbs up in Slack when you've done that successfully. And if you want to comment out the previous code that you wrote to create students, that's cool. Otherwise, you're going to keep creating new instances of everything in that schema.js file, but that's all right. So Matt has a good question. When looking at the terminal, why did the output reverse the order of unit and title? Sorry, can you guys hear me okay? I love these AirPods. It's a game changer. I wish I could buy them for everyone for remote, but the battery life is super brief during the day, so I'm having to use one at a time. My other one just died. Anywho, asks, when looking at the terminal, why did the output reverse the order of unit and title from how we put it in the schema.js file? So that's a good question. And the answer is, when we're creating objects with keys and values, you should never assume that the keys and values are going to be in a particular order. Remember that the array data type, you can be assured that that index is going to stay consistent. But with an object, most of the time, stuff will be returned in the order that you saved it, but you shouldn't count on that. There's no rule that says an object has to be the same way every time. And that's the beauty of keys and values, right? Because if I want to find a value, I just type in the key. The order doesn't really matter inside of an object. Yeah, so that's the reason for that. Alrighty, we got 3 thumbs ups. So far we've covered the C in create while you guys keep working in CRUD, create, read, update, delete. We've done create. To play around with read, update, and delete, the next thing I want to do is we're going to add some data to that seeds file just to quickly kind of bootstrap some more dummy data into our database. So that's what we're going to do next. And I'm actually going to give you some code to copy just to make it a little quicker. And I'm going to answer Matthew's question in Slack just so we have it on record. All right, cool. 8 thumbs ups. So let's see some more data. This is going to be a couple of steps. So just let me walk through it real quick, and then you guys can follow along. I'm going to share my screen again. So the first step, since I'm going to be creating new instances of students and projects in a different file, I need to export my models from my schema so that other files can have access to them. So this is another example of how handy that module.exports is. It's a really great pattern that comes from common.js, which is another library under the hood. So let's do module.exports. And remember that module.exports is just a fancy object. So let's export the student model so other files can have access to it. And I'm just going to make this equal to student model. And then we'll do project model. And this is going to equal the project model that we created above. So I'm just naming it the same thing. A key of student model is going to equal the student model up here. And the same thing for project model. And kind of in the same spirit of what the question that Matt just asked, in this module.exports, the order doesn't matter inside of this object. We could have put project model, then student model, or the opposite. It doesn't matter inside of an object. So that's the first step. And then we're going to go to our seeds.js. And this is the code. I'm just going to put this into Slack, and you guys can copy this. I'll walk through it. But this is just some dummy seed data. So let me walk through this real quick. So on line 1, remember, similar to Express, whenever we want to import or whenever we require the functionality of a given NPM module inside of a file, we need to require it. So we're requiring Mongoose here because we're going to be using some of its methods. In this app, or in this file, the schema, I'm creating a variable schema and I'm requiring the schema file, right? And so this is essentially the module.exports from schema.js. So this object, it's essentially the same thing as doing this. So now my schema is going to equal the keys and values, student model and project model, because I'm requiring that file. I'm going to create a student model, a variable student model, and that's going to equal schema.student model. So I'm just naming everything like the same thing to be consistent. But if I put my module.exports in here, for example, the way that I can get to this student model from the other file would be schema.student model, right? So I'm grabbing the key of student model for my schema object. So that's essentially what's going on right here. So I'm going to create a variable so I can create new instances of it inside this file, but it's essentially schema.student model and schema.project model. Again, I'm doing this to be really dry because I'm going to be reusing this variable. I could totally just do like, new schema.project model if I wanted, but I'm just trying to break it out for, for dryness sake. Right here, this code, this .remove is a Mongoose method that will remove every instance, every document from a given collection. So just before I seed my database with fresh data, just let me delete all of the student models from my database, all the students, and let me delete any project models that exist inside the database. This is really not, this probably isn't even necessary since we aren't saving projects separately from student. Because when we delete a student, since those documents are embedded on a student, the project should be deleted anyway, but just to be consistent, I put that in here. And then this is just 3 new students, Becky, Brandon, and Steve. This is similar to what we did longhand a few minutes ago, and then some projects. And then down here, I'm doing a for each just to dump some new students and such into our database. So yeah, just adding some new stuff. And then here, I can run node db seeds.js. And remember, it's going to erase all of the people that we just made. Actually, I say that with a caveat. If we really want to do this properly, you can comment out like Chuck and Anna. It's still going to run that code because we're requiring that file. So it's still going to like recreate Chuck and Anna and stuff, and that's okay. But what this file is doing is it's deleting all the students and projects, and then it's creating fresh new data. And that's what a seed file is good for. Let me paste this into Slack and give you guys a second to do that. Any questions about the seeds file and such? We've mentioned it before. Let me stop my screen share while you guys do that. Seed files are really handy. It saves you a lot of trouble. If you have data that, let's say that your database explodes and you're gonna have to like start from scratch, maybe you wanna seed your database with some dummy users or some dummy information. But the example that I always use is, let's say that your app depends on the abbreviations for like the 50 states, right? That information isn't gonna change, although, who knows what's gonna happen once tomorrow happens. Who knows what's gonna happen in the next 4 years, but I think Puerto Rico may be an official state, who knows? But the point being, if you have some sort of hard-coded data that isn't going to change, sometimes it's handy to put that in a seeds file. And then if your database explodes or whatever, you don't have to type that stuff in manually. You can always run that file again and just upload that fresh data to your database. So anything like that, sometimes it's a good idea. And we'll be using some seeds this afternoon as well. So we'll see this again. We're gonna see all this again, actually. We're gonna build another app, another CRUD application, except this afternoon, we're gonna build it within a Node and Express application. So right now we're doing all the Mongoose stuff and making sure that that works. And this afternoon, we're going to use pretty much the same code and put it into a Node Express app. And then tomorrow, once those two steps are working, you guys will put views on top of that. So we're, trying to build this in a very thoughtful way. So I got 4 thumbs ups. So we're doing pretty good on time. We've already done the create from our CRUD. Next, we're going to do read and then update and delete. And I think we'll be able to hit those before lunch. So we'll be in good shape.
I have a question. Do we have to do the part where it says let's test if it worked? So putting Mongo in the terminal.
Sorry, Alejandro, one more time.
Do we do that last part where we're testing Mongo? Show database.
Oh, yeah, we're going to give you guys some like Mongo stuff tomorrow. If you want to play around with that, I would open up a new tab in your terminal and go into the Mongo shell itself. But in the interest of time, we're going to give you guys some exercise with that tomorrow. Again, that's essentially like going under the hood and tinkering with your engine. Today we're just trying to learn how to drive in the time that we have. But yeah, still waiting on 3 more thumbs ups. Yeah, let me share my screen and I'll walk you through that really quickly while we're waiting on folks. If you want to test out, or if you want to go into the Mongo shell itself, there's a couple of commands right there that's in the README. I'll do this really quickly because we're going to cover this tomorrow. But what you can do is you can go into Mongo, into the Mongo shell. So type in Mongo, and that'll you'll be attached to, you'll be going into the Mongo engine, Mongo database. To see all of the databases that you have available, you can use show DBs. And this is, essentially, these are all the apps, all the databases that I have right now. And remember that each app is probably going to have its own individual database, so that you will not have this many. But you should have a students database. And I have that one right here. So that's the one that we're using currently. And remember that Mongoose created that for us the first time that we saved some data to our database. And we told Mongo the name of the database here with this mongoose.connect. And we said, go to our local version of Mongo, our local database, and create a new one called students. Now, if I want to go into students, I can use the use students. So the use keyword is how you actually get into that database to see the data. And this says switch to DB students. So now my students is attached to a variable called DB under the hood. So if I type DB, I can see that I'm in the students database. So if I want to see the collections that I have available, you can do show collections. So remember that collections, you can think of them as like filing cabinets with each individual document that we create. Again, we're not saving projects separately. We're saving projects inside of students. So that's why we only have one filing cabinet for students. If I want to see all of those students, we can do kind of the quick way is you can call the .find method. So .find is the Mongo method to find whatever documents you're looking for. Just putting in empty brackets and empty object is how you find all of your stuff. If I wanted to find a particular student with the name Anna, I could put that specific criteria within that query. But that .find is kind of like the basic, just give me everything, give me the index. And then another quick little thing, because that's a little messy, you can put .pretty with parentheses. That's another Mongo method. I've got my thing magnified, but what .pretty does is it just gives it a little bit more spacing, so it looks more object-y. So if you shrink this down, it makes it a little bit more readable, right? So these look more like objects, and you can kind of like see the hierarchy. So that .pretty is a handy method to clean it up a little bit. But yeah, so that's why we're console logging everything, so we're not going back into Mongo each time just to confirm stuff. Yeah. We have 6 thumbs ups. So waiting on 2 more, and then we'll move forward. Seven thumbs ups. Okay, cool. So I'm gonna still typing, not sure everyone else. Okay. That's okay, Karen. So I'm going to move forward, and then at the next stopping point, I can help you get up to speed if you need to. So here's our next step. Uh-oh. Oh, that's the wrong screenshot. Excuse me. Let me take that one more time. So if you go to the Mongoose documentation, again, there's a lot of different methods that Mongoose gives us out of the box. These are just a couple. So right now we're going to write some code so we can read the information from our database. We just used the .find method. There's also find by ID. So if you know the specific crazy BSON, hash object, if you know that ID specifically, you can go ahead and find the exact document student, if you will, that you're looking for. There's also find one. So the .find one method, it finds the first instance of whatever you're looking for. So if I have 10 students named Anna, that find one is going to just return the first one it finds. And then that .remove, model.remove, we saw that in our seeds file. So that .remove just completely wipes out your collection so you can start fresh. Those are just some really common ones. And we're going to look at some of those here in this next step. So what we're going to do as we get started, we want to mimic, to the extent that we can, the folder structure for how we're going to be creating our full stack apps going forward. So we're going to move some logic out of our schema file. We're going to create a student's controller file that we're going to put some code into for our more complex queries and stuff. We've already tested out how to create new students and create new projects embedded on a student in our schema.js, but that's a little janky. So let's do this the proper way and have a separation of concerns. So the first thing I'm going to do, and if you guys just want to hold on for a second, let me walk through this. Can you guys still see my screen, my Atom and my terminal? Okay, cool. So I'm going to create a directory, controllers directory. And then inside here, let's just create a student's controller. And again, I could put all this code in schema.js if I wanted, but I'm just trying to keep this a little clean. This afternoon will be a little bit more proper with separating our code out. But so I'm going to add this controllers directory and then the student's controller JS file. So remember that it's students, it's plural. That's the convention, because this will control all of the students, right? Models are singular because a model is kind of the template for what a single instance of something looks like. So models are singular, controllers are generally plural. That's the convention. So we're going to follow some RESTful routing. We're not going to create routes. We'll do that this afternoon, but we're still going to follow those RESTful conventions and using our controllers to listen for incoming requests and communicate with our database. So we don't have an Express app right now, but we're going to write this code to kind of mimic requests and responses just to test it out. So let's get started. The first thing I want to do, let's go ahead and open up the student's controller. I'm going to add this code. I'm going to just dump in the first part, and then I'll walk through writing out the actual query. So remember, anytime we want access to some other file, we need to require it. So this first line, I'm pulling in the schema.js file because that's where my, my models live, my student model and my project model. And just really quickly, just take note of that path. So right now I'm in the controllers folder, right? Because this is students controller. So I have to go up a level and then into databases and then into schema. So, just take note of that path right there, the relative path. And then similar to what we did in the seeds file, I'm going to grab the schema.student model and the schema.project model so I can create new instances of students and projects. So that's pretty much the same code from our seeds.js, right? So we brought in the schema, and then we still are using those models, essentially. The first thing we're going to do is create an index. We'll pretend that we're creating an index view. So remember that index views, following the RESTful pattern, shows all of something. It's just going to return all of the students or all of the users, whatever resource that we're trying to access. So we're going to try to mimic that. Let's create, or I'm going to create it and then give you guys a second. I'm going to create a students controller variable. So we're going to create a big fancy object. There's several different ways, multiple ways to set this stuff up. This is just one way to do it. So just letting you know, I like this pattern, which is why I'm using it, but you'll see several different ways to set up your stuff. But I'm going to create a fancy object with properties, or actually methods, because they're all going to contain a function with my Mongoose queries. And the first one I'm going to do is index. And then this is going to contain a function. So I'll open up that function. So essentially, I want to put my Mongoose code, all that Mongoose query stuff inside of this function. So when I call students controller.index, I want it to return all of the students. Now the way that I do that is with the .find method. So I showed that in the over here in the Mongo prompts when we went in here. So this .find is the Mongoose method to return all of something. So that's the code that we're going to write in here. Specifically, I want to return all of the all the instances of the student model. So this is the Mongoose query. And the queries take a callback right here. So when you want to do something with that data, if I want to return it, if I want to do something else with it, it takes a callback function. Just for grins, I want to show you guys kind of Mongoose's built-in promises. So Mongoose's built-in promise object is called .exec. So in all of today's coverage, I'm using .exec. Remember that promises are just another way to write a callback, but just so you guys have seen this method .exec, I'm going to use that. So once I find all of those students, I want to console log it and then eventually like send it to my view. So .exec takes a callback function. And remember that the whole point of using promises is that queries can sometimes take a while to finish. Right now we just have like 6 or 7 students, so it's not a big deal. But if we had thousands and thousands of students, that query might take milliseconds or whatever. So it's a good idea to have a promise or a callback to make sure that that data is successfully retrieved before we move forward. So this callback, hopefully you guys will notice a pattern in today's stuff. It takes the error, if there is one, And then the second argument is going to be the result of this query. So I could have named this students. I could have named this anything. But the Mongoose documentation, to be consistent, it usually just refers to these as documents, because that's essentially what they are. Each individual student is a document in our database. So they use the abbreviation docs, short for document. So to be consistent, I'm going to be using docs, although you could name this whatever you wanted, right? So down here, we're going to put our boilerplate error handling garbage. And you could actually get away. You don't have to write the error handling here. You could get away with it. But if something does break, you probably want to have some good error messages. So if there's an error, console log the error. Otherwise, down here, clean this up a little bit. I'm going to do docs for each. So I think in our stand-up today, somebody mentioned the for each method. It may have been Matt. So here's just another look at it. So I could have done a for loop here if I wanted, but for loops generally don't want you to use a function inside them. It's not a good practice, but for each takes a callback, and the callback function takes a parameter, whatever you want to call each thing that it's iterating over. So Mongoose is going to return an array of students or documents. So in this example, for each one that I iterate over, I'm just going to call it a doc. I could have called that student or, whatever I wanted. Then let's console log that. Oops. My Atom is barking at me, so let's clean this up. Cool. And then the way that we're going to call this to keep things simple is I'm literally going to call students controller, and I want to call the index method in my students controller. So when I invoke .index of my students controller, it's going to fire off this function, which is a query to my Mongoose database, and then I want to see it console log each student. So let's see this in action. So I'm going to go to the command line, and I'm going to run this with node. This time we need to go into our controllers, and let's run this file. So when we run that code, it does indeed console log out all of these student documents that are in our database. So that is a successful index method. So consider this afternoon, we're going to add some logic to an Express app. And essentially, we would send this data to our browser, bake it into a view. Well, with handlebars, we would do that on the server. But yeah, this is exciting stuff. We're super, super close. We're like a day away from a fully functioning full CRUD app. In any event, let me give you guys a second to catch up. So I'm going to stop my screen share and answer any questions that you have. And then just take a second and get that up and running. So go ahead and get your index working. And then give me a thumbs up when you get that working successfully. If anyone needs any help or has any errors, because I just went through several steps there, just let me know. We'll get you through it. And then when you're finished with that, go ahead and give me a thumbs up in Slack. We're pretty darn close. I don't think we'll get through everything, but we'll just pick it up after lunch. And then we'll hop into our Express app. But we've covered a lot today, so this is good. record. We were pretty much at the finish line. So the idea was this morning, we were just focused on Mongo and the queries. This afternoon, we're going to create a Node Express app and pretty much use the same, we're going to use different models, different topic, but we're going to use pretty much the same queries to put into this Express app. So the goal for this morning was to make sure that we're comfortable with the queries, or if not comfortable, we want to make sure that they're working so that we have working code, to see that same code again this afternoon. But before we move into the Express, let's take a few minutes and just wrap up this morning's coverage. We were pretty much there. The only extra queries we needed to create is the show. So if you want to show one of something, an update and a delete. So I want to take a quick peek at what that looks like before we move forward. And again, we're going to see all this again, this afternoon when we get into Express. So let's start with the show route. And my apologies, I do appreciate that today it's been a lot of me talking. I don't like to do it that way. And it's not always that way, but unfortunately, sometimes the coverage, just there's really no other way to do it. So I'm going to try to give you guys as much time as possible this afternoon to practice this yourself. I'm definitely aware of that. I get sick of hearing me talk. So I put the lesson readmes back into Slack, but let's pick up where we left off earlier. I'll paste in, Chuck is still bogarting all of my output. Okay, so let me get you guys started on the next step, and then Kieran, we can share your screen while you guys are implementing this. Well, let's take a look at the, oops, let me do another screenshot. Beg my pardon. We did index before the break, so let's see what a show query would look like. So I'm going to share my screen and walk through this. If you just want to, hang tight for a second, I'm happy to answer any questions you have, and then I'll give you guys time to implement this in your app. So we're in the students controller file. So remember before lunch, we created a controllers directory and created the students controller.js. And this is where we're mimicking all of those RESTful methods. So we have an index. That's what we did before lunch, which will show all of our students. So let's add on to this. Let's create a show, kind of a show method in the students controller to represent if we wanted to show one of something. And I'll just type this out. So let's add this show, and this is going to take a function, right? Because it's a method. And when we get to Express a little bit later, so remember that Express deals with requests and responses. So eventually, we're going to take that request from the user and figure out exactly which student they want to see. So remember, we'll have something like URL students / and then an ID for the student. So we're just kind of mimicking that here, and we're just going to pass in a request. So this isn't a literal request from the front end because we haven't built a front end yet, but I'm just going to use the request parameter just to represent that we're getting that request from the browser. So let's pass in the request to this function. And then all of these are pretty much going to start with the student model because in our Mongo database, we're looking for instances of students, the student model specifically. For this one, let's use a method called find one. So there's several different ways to grab one of something in Mongoose. I put that screenshot into Slack. There's a find one. So find one will find the first instance of a particular criteria that you pass in. So if I had 10 students named Anna, find one would just find the first one that it comes to in the database. There's also find by ID. There's also, what else is there? There's a couple of those, but find by ID and find one are usually the most common. In find one, you can pass in whatever parameter you want. So find one with the name equals Anna or the age, equals 30 or whatever. Find by ID obviously is just you're passing in the ID, and Mongoose knows what you're passing in is a object ID. Anywho, for this example, we're going to look for the name that equals the request.name. So we're going to create a request object just to kind of mock up getting a request from the browser. And we're going to get the name specifically from that. I'm going to use our Mongoose promises method called .exec. It's pretty much just another way to write a callback. And this exec method also takes a callback function, essentially. I know that's a little redundant, but that's how promises work. And again, the great advantage of using a .exec, using promises, is that if we have some really complex query, we're able to chain those together and it's much more readable. So I just really like using .exec with Mongoose. But if you're more comfortable with callbacks, you know, they work pretty much the same. So you're welcome to do that if you're comfortable with that syntax. So our callback, hopefully you're already seeing a pattern between this and the index query. We're going to pass in the error object, if there is one, and also the docs. So remember that the docs just represent whatever we're grabbing from the query. So whatever student model.find1 returns, it's going to get passed into this .exec promise method as whatever we call this argument. So we could call this, you know, student if we wanted, because we're grabbing one instance of a student. But I'm just trying to be consistent with the Mongoose documentation. And they usually use the term docs, which is short for documents, because literally we're getting the documents from our database. But again, docs is just an argument, or a parameter rather, and you could call it whatever you wanted. We're going to use our pattern from above. That should be familiar. So if I have an error, just let me console log it. A lot of this is just the same, you know, pattern. Probably 80% of these queries are like the same structure and pattern, and hopefully you'll get familiar with it. And since we don't have a front end yet, let's just console log our docs. In this case, the docs should be the one student that we ask for. And let me clean that up with some semicolons. And then let's actually invoke that show method. So I'm going to comment out index, and let's run students controller, this time the show. Let's test it out. And then I have some code in there. I'm just going to look for the document where the name is Becky. And remember that we're using this find one method. So if I have multiple Beckys, it's just going to grab the first one it finds. And then that needs to be an object, obviously. Cool. So go into the database and find me an object that has the name of Becky. Find me a document with the name of Becky. Let's make sure that that works. So over here at the command line, I'm going to run node controllers, the student controllers file, students controller file. So let me run that. So we get our connected, and then I do get Becky returned. This stuff, Chuck and Anna, if you want to do this, I don't want this to be confusing. That's running because the schema file is still running because it's connected to the student's controller file. So I'm going to comment out, and you guys can do the same just so you don't get your wires crossed. You can comment out like when we created Chuck and Anna. That's where this stuff's coming from. It's coming from the schema file. So if you want, I would suggest commenting that out if it's a little more clear. So I'm going to run that again. And now we're only getting the student controller.show method. And there we go. So it's grabbing Becky. We can see her projects. So we seeded Becky with 2 projects, and those are here. What do we call these projects that are inside our Becky document? What's the term that we use for this? What do we call these documents? You can put that into Slack if you want. What's the great advantage of using Mongo? How do we save projects on our student? What's the term for that? I saw Sophia typing and then she stopped typing. So these projects are considered embedded documents, is what I was getting at. Maybe I didn't phrase the question succinctly. But remember, that's the beauty of Mongo, is that instead of putting the projects in a separate place, let's embed those project documents directly on our student document. So it's super fast, super easy to find when we run those queries. So this projects array would be considered embedded documents. Cool. Okay, so let's pause right there. Go ahead and add the show method to your student's controller. And remember that you can test it out with this command. I'll just paste this into Slack because I don't want to type it because I'm lazy. And then run that command on the command line just to test it out. And I will stop my screen share for now. And I see Kieran typing. Yeah, so if anyone has any questions or needs any assistance, go ahead and let me know. And please give me a thumbs up in Slack when you implement your show method. So I'm going to paste a link in the party time channel because I don't want to dirty up our main channel. But somehow a while ago, I got on like the MongoDB mailing list. And if anyone's like super fired up to go meet a bunch of folks and learn more about Mongo, Mongo World 2017 is happening soon. So if you get OS in Chicago, June 20th and 21st. So if anyone's interested, in just immersing in MongoDB for 2 days, that's where you go. I hear the after conference parties are pretty crazy. MongoDB is very unstructured, and I hear that the after parties are as well. That's an awful joke. I apologize. So if anyone wants to swing through the Chicago area. Okay, Audrey, you were first. Audrey, you want to share your screen? We'll take a look at your syntax error.
Yeah.
Okay, so let's take a look at the terminal. So walk me through this. Where should we look for this error?
Well, it's saying is on line 20. So that it is having a syntax error right here. But I'm not exactly sure. It said an unexpected token was this, but I'm like, if it's a function, why would that be the case?
Yeah, so I'm not sure. Okay. Can you make that your atom larger? Let's see the rest of your, I think I see the problem. Okay, so that show method on line 20 is part of our student's controller object. So that needs to be inside the student's controller that starts on line 5. Does that make sense? So we already have an index method on line 6. So on line 15, I think it's line 15, I would put a comma there on line 15. And then on line 16, paste in. No, no. So on line 6, you see the opening curly brace on line 6. Click on that, and see on line 15, that's where that method ends. Put a comma right there at the end after the curly and hit enter. And now we're going to add a second method called show. This is where you should put your show code. So we're building a big object called students controller that's going to have methods for each query. That's the idea of what we're doing.
Sorry, I think I have the same problem. I just missed the solution. Can I share my screen up there?
Yeah, can we finish here first?
Oh yeah, of course.
And well, Kieran actually was next in the queue, so we'll hit him next. Okay, so what line should we look on for this one?
25.
Nice. Yeah, so I think we just need to close up your student's controller. I don't think we've closed it up correctly. So see on line 22, you have those 2 curly braces. So I would hit enter in between them. And okay, and then scroll up to where your student's controller starts on line 5. So now you need to see where that closing curly is. See how there's an underline? So let's see where that is. I think we just need to, I think line 26 is the end of it. So I think you want to move that curly on line 26 up to like line 24.
Looks like it's matching. It's on line 23 is what it's saying. That matching one is line 23.
Okay, great. So let's look. So check out your show method and let's see where that closes on line 16.
On line 22.
Okay, then let's get rid of line 26. You may have an extra curly in there or something.
Gotcha.
Okay. Okay, so let's run the code. I would comment out your student's controller.index method on line 27, just to make it a little cleaner. On 27, yeah, let's just run the show method and let's see what happens.
No, syntax on 17.
Okay, yeah, I think it's a curly. So Audrey, do this. Go ahead and unshare your screen. Take a second and just make sure that everything is closed correctly. Because if you look at your indentation, I don't see a closing curly for your student's controller. I think it's just like closing something off. So work on that for a second and let's take a look. Kieran, if you're still getting that, we'll come back to you. But just see if you can like, if something's not closed correctly. Kieran, okay, so you want to share your screen, Kieran? So by the way, we're gonna cut this off at like 3:05. Wherever we are, we're gonna stop and we're gonna move forward with the next lesson. Because we've got a lot we still need to get through, just FYI.
Okay, so I'm getting this error.
Okay.
And so
let's see here.
I don't know. Module.js throw error. So
Okay, so it can't find a module. It's an intro lesson. Okay, your path looks okay. So Kieran, it's students controller. Your file is called controllers. It needs to be controller singular in Atom. So rename that file.
this one?
Yes. That should be students controller singular. And then run that command again. And I think you'll be okay. Cool. So nice work. So you didn't get any errors. I think maybe you didn't seed your database correctly because you're getting null return.
Mm-hmm.
So I think maybe you don't have stuff in your database, I think. So let's run node space db/seeds.js. Let's run that seeds file. It's plural, seeds.js. Okay, so hit the up arrow twice. And let's run that. Okay, yeah, run that command one more time. Let's see if you can. There you go. Okay, you just had not seeded you didn't have anything in your database, essentially. Okay, and then Alejandra, we'll take a look at your stuff.
I got it. It was a curly bracket.
Oh, cool. Okay. Audrey, how are you doing?
It's saying that it's not a syntax error, that find one is undefined.
Okay, great. You want to share your screen? Let's take one more peek, and then we need to move forward. I can help you at the next break. Let's check this out. Okay. So you're getting, can I read property find one of undefined? So student model is not being defined somewhere. So let's go back to Adam. Scroll up to the top. Student model schema. Okay, that looks okay. Did your index route work? When you ran index earlier, were you able to see all of your stuff?
Yeah, I mean, I didn't have a problem before.
Okay, so Audrey, on line 33.
Mm-hmm.
Oh, so that's closing off your show. Okay.
Can we try to run a .index method again to see if it works?
Sure. Yeah.
Yeah, and you can just comment out the show method.
So
same command that you run node controller. Yeah.
Yeah.
Yeah. So
yeah. So sometimes that was student model.
Can you go into your schema.js and go to the bottom?
Go to
the bottom where we have the module.exports on schema.js. Yeah, you might have not exported the models that we need to import in our controllers to use. Yeah.
Yeah, so it literally can't, like, it's trying to call student model, but it doesn't know what that is. Yeah.
Gotcha. Okay.
Yeah, and I'll paste the code in the whatever.
Thank you.
Yeah. So if you add that, it should be fine. Hopefully.
Yeah. A lot of moving parts for sure. But yeah, Cody's right on. I think that will get you working. So how many thumbs ups did everyone else? If you got it working, if you don't mind, give me a thumbs up, and we'll move forward. So I'm gonna, in the interest of time, I'm gonna share my screen and let me walk through update and delete, and then I'll give you guys a few minutes to incorporate that into your app, and then we're gonna move forward with our Express app. So let me share my screen again, and we'll knock this out. And we're gonna be using these queries this afternoon as well. So you're definitely gonna see these again, not to mention with your homework and such. So, I don't want you to feel like you're not gonna see this stuff because you definitely will. So let me paste in our update. So we just need to do update and delete. Remember that we don't need to worry about the new or the edit because those contain forms, which would require a view, and we're not dealing with views yet. So we're not quite having to worry about all 7 RESTful routes, right? We're just dealing with the ones that we can play with without a view component. Yeah, I love one tab. Yeah, is anyone interested in some stock tips? All right, so let's work on the update. Let me go ahead and comment out students controller. And let's add an update method. Actually, let's do this. I'll paste all this method. I'll push up all my code shortly. But if you guys want to code along as I'm doing this, feel free, and I'll just kind of like talk through it. And if you guys have any questions, but go ahead and feel free to like code along with me if you want. That'd be cool. So since we're adding a new method to our students controller, again, make sure that you're inside the students controller object. Make sure that you put a comma after your show method, right? Because we're going to add another method called update. So I'm just going to put the shell of it here to start. And then for this one, let's pass in request and update. So again, with an update, we're updating one instance of something. So we're going to kind of mock that up with that request parameter, REQ. So we're going to tell Mongo precisely which one we want to update. So we're going to pass that in. And then we're also going to pass in this update parameter because we're going to call that here in a second. So this is going to start with student model again. All these should start with student model. And for this one, we're going to call find one and update. So you can probably figure out what this method does. This is a Mongoose method. There's a couple of ways to update data. This is a pretty common one, find one and update. So it's going to find the first instance of what you're looking for, and that's the record or the document that it's going to update. And as you type this out, make sure that this is camel cased correctly, because this is kind of a tricky one. So just make sure that you have the capitalization correct on that. Now, if you go through the Mongoose documentation, this method takes a couple of objects that we need to pass into it. The first thing that we need to pass in is the name or the criteria that we're looking for. So in this case, we're going to look for a document with the name field that equals what we're going to pass in. So we're going to look for Becky's record again. So if I was going to look like, for a record with an age of 30 or whatever, we would pass that in. But we're going to find this document by the name field. So that's the first parameter that we pass in. The second one is the new information that we want to update. So this, we're going to pass in Becky. And so once we find Becky's record, let's update her name. Well, we'll do that when we actually call it. But we're going to have an update name object. And so that's what we're going to tell Mongo the name that we want to update it to. And this last parameter is optional. I like to include it. This new :true. This is in the Mongoose documentation. All this is doing is when you update a record, do you want to see the previous record, the state of the previous record that you just updated? Or do you want to see the object with the updated information? So do you want to see the new object post update? Or do you still want to see what it looks like before you tried to update it? So that's what this object is doing, the new :true. So that's kind of a good practice because I want to make sure that my updates were in fact persisted to the database. So show me the new version of what I just updated. Cool. So in the lesson, in the screenshot, that's all on one line. Here, since I'm magnified, it's on 2 lines, but that's okay. So let's add our handy dandy promise here. And remember, this is just a pretty similar pattern. So we're going to call the .exec, the Mongoose promise object, and then we're going to pass in the error object and the docs object. So remember that the docs, whatever we call this parameter, this is what is being passed in from the query. So whatever this returns is going to get passed into this function as this parameter. And then down in here, again, we're going to rinse and repeat. This should look familiar. So if there's an error, let's console log it. Otherwise, let's just console log. Let's just see what the new record, the new document looks like after we've updated it. And let's call it. let's see what happens. So we're going to call students controller. This time we're going to try the update method. So when we call this method, remember that we need to pass in two things: the criteria for the record that we're looking for, and then what we want to update that record to. So here, let's pass in two objects. The first one is going to be name of Becky. So it's going to find the first document that has a name of Becky. And then the second we're going to pass in is what do we want to update that to? So in this example, let's just update it to Sarah for funsies. Cool. So let's run our code again. I'll hit the up arrow and run controller students controller.js. And there we go. So now I have that record has been updated. If we check this out, we'll do it in the next lesson. But if we checked out this record before we updated it, the ID should be the same, right? We're not creating a new record with the new ID. We just updated what Becky's record was. We just updated it to Sarah, the name. So if we'd have checked this out before we ran it, actually we could do that. Well, I already cleared my terminal, but I was about to say if I had the history, I could just scroll up. Maybe some Mongo here. So this was Becky's object ID. Of course, I added Becky a couple of times. That's no worries. Anyway, the point is when we update a record, the record already exists, right? So the ID shouldn't change. The ID would be the same. So that's update. Let me show you delete, and then we'll take a quick timeout. Excuse me, and then let you guys add this code. So delete is a little simpler. I'll paste the code into Slack. And actually, if we had more time, I would put you guys into breakouts and have you take a stab at this, because I think if you had a little bit of time to go through the documentation, Mongoose documentation, you guys could totally maneuver your way and figure this stuff out. We just don't really have time for this lesson for you guys to do that, but you can totally go through the docs and come up with this stuff. So let's add the final one for this lesson. Let's add the delete method. Mike says, tried at lunch, it was awful. Yeah, but you guys are gonna be pretty slick on this stuff in no time. But the truth is there's good documentation and bad documentation. Mongoose is not the best documentation, I hate to say. It's really obtuse, and sometimes it's hard to really decipher, and the examples aren't always super clear and crisp. So unfortunately, Mongoose is not the most user-friendly documentation, which kind of stinks, but that's typical. Some APIs and some libraries have great documentation and others don't. There's 5 million more functions, yeah, for sure. But you don't have to know all of those. We're going through like kind of the basic greatest hits that you're going to need to know to build a CRUD app. So this is going to be plenty to get you.
Can't find the greatest hits among the 5 million though. That was the issue.
Yeah, that's true. Yeah, it's like the needle in the haystack. There's like so many options. I totally hear you. Yeah, I probably need to add a comma here. I'll take a look at that in a second. So we're actually going to call this method destroy, because technically the RESTful convention is to call the delete method. We're calling the delete HTTP verb, but typically this is called the destroy method or the destroy action. So to maintain consistency with the convention, we'll just call this destroy. But you guys can probably, I'm sure you could do this on your own, figure out where this is going. So since destroy, we need to tell it the specific document that we want to destroy. So again, we're gonna kind of, fake this. We're gonna pass in an object, find Becky's record or Sarah's record and delete that one. We need to tell it specifically. So you guys, again, probably are seeing a pattern. So this query, we're gonna start with student model. And then for this one, we can use find one and remove. So remember in our seeds file, if we do .remove, that's just going to remove everything from our database, like all the students or all the projects if we had a separate collection for them. And Mongoose also has a find one and remove. So this is how we could remove one thing. I think there's also a find by ID and remove. So once we actually get to passing in requests with our front end, maybe you want to use that method, but it's going to do the same thing at the end of the day. So this takes an object. We need to tell Mongoose again, like which object we want to delete. So we're going to pass in the name of the field name. We want the value of the document we want to get out of there, to 86 out of our database. There's our old promise exec function that takes 2 parameters like the other 3 times we've done this. So you should be able to do that in your sleep after you do this a few times. Pretty boilerplate. Most of this stuff is the same pattern over and over. This is definitely, you've seen this before. So if there's an error, just console log it. There's more complex stuff we can do with our errors. We're just not like going down that rabbit hole today, but you can definitely do a lot more with your error handling versus just console logging it. Just FYI, there's definitely more complexity you can do. And then let's console log our docs. So this is going to console log whatever we just deleted. So let's check this out. To run this, yeah, Kieran's right. I did need a semicolon there. Let me comment out our update method call, and let's try delete. So let's do students controller delete, and then let's try to delete the record with the name of Steve, and that's lowercase. So that should have been one of our seed data, seed students. And then we'll run it over here. And what did I screw up here? Line 45, students controller, delete.
It's called destroy.
Oh, thank you, yeah. Yeah, thank you very much. So again, delete is the HTTP verb we will use to perform the destroy action. Yeah, thanks. All right, let's try that again. Cool, there we go. So we just deleted Steve's. So it was returned to us, so we could console log it, but it's not in the database. And if I want to confirm that, let's call our handy dandy index method. And let's just make sure that Steve has been booted from our database. So I commented out destroy and uncommented or decommented, whatever you want to call it, our index method. So I'm just going to list all of my students, and let's see if he's in there. So this lists everyone, and yeah, looks like he is gone. So we've got Chuck, Anna. Man, we've done a lot of students today. Sarah. So remember that this Sarah was Anna. This is the one that we updated. Brandon, Chuck, Anna again, because I ran that a couple of times. Yeah, but Steve is no longer with us. Rest in peace, Steve. So there we go. Let me stop my screen share, and let's take a few minutes and let you guys get up to speed. I'm going to push up my code if you want it for reference, and then we'll get started on the next coverage at like 3:20. So if you guys want to stand up and stretch, or if anyone's having any issues, we can debug it now. And I'll push up my code, and we'll move forward at 3:20, just FYI. So let me know if you're having issues, and we'll straighten it out. And again, if this isn't like clicking, it's okay. We covered a lot this morning. We're about to do it all again, but using Node and Express. You're going to do it again for homework. You're going to do it again tomorrow, but put views on top of it. So this is a rinse and repeat type situation for sure.
I have a question. I just noticed something. For student controller, when we were doing the show, we said to show the student named Becky, but I definitely don't think any of my data says Becky, and yet it showed everyone I have instead. Is it, or am I understanding it incorrectly? Because if I run show named Becky and I don't have a student named Becky, I still got back the 3 students I did have.
Well, your show method should only return one thing, right?
You might have not
Yeah,
commented out your index method, because I remember we put it back in to test if it worked.
Oh wait, no, sorry, I just did it again. It says null. I guess I wasn't seeing that little null under there, but I think it goes through. It looks like to me, just confirm. No, it lists everybody, and then on the very bottom it says null. So it does still object out the other three.
So null just means in one of, go ahead and share your screen. Null is not necessarily a bad thing. It just means that it can't find something. So maybe it's still running one of the uncommented out methods because we haven't used the return keyword in any of our code today. So generally you would use a return to return something specific. The default return from these Mongoose queries is just null. It's not a bad thing. It's like the default in JavaScript, if you don't explicitly return something, it says undefined, right? That doesn't mean it's a negative. That's just like the default return value is undefined.
Yeah, I guess my question is if it's supposed to show back the student Becky, but I have 3 students, Anna, Audrey, and Matthew. Why would it show those 3 students and not just tell me?
Yeah, because I think to Cody's point, we must have something not commented out. So let's look at your show.
I feel like it might have been in the other files, because reading the console, it says all those students was saved to our DB. So it leads me to believe that we might have left something on.
Yeah. So yeah, Audrey, go to your schema.js first. Let's check that first. So yeah, to Cody's point, those I think you're seeding your database or saving it, and that's just the return value because we were console logging when you create new instances. So was saved to our DB. So see on line 75 there in your schema, that's what you're console logging. If you look in your console on the very last line above null, it says was saved to our DB. So you're actually, so I mentioned that earlier, I commented all of that stuff out just to avoid confusion. So go ahead and comment that out from schema.js. Because since schema.js is connected to our students controller file, whenever we run students controller, it's also going to run schema.js again. And then I would comment out, all that stuff. Yeah. So your code's working great. The reason you're getting null is because there isn't a student named Becky in your database. So let's go back to your show where you invoke it, and let's pass in capital A, Audrey, instead of Becky on line 32. Let's get it to return Audrey.
Okay.
There you go.
I was expecting null, but I was confused why I saw everyone else.
Yeah, null just means it can't find it. Yeah, but your code's looking great.
Thank you.
And I just pushed up my version. Let me put that into Slack again, if anyone needs it for reference. All right, friends, let us move forward. I'll give you guys another little bit of a break before we get to lab time, because we're about to build another exhaustive Express application. But before we dive in, again, just kudos on what we've covered so far. We've covered a lot of ground, and you're going to get a lot more practice with this stuff. So I know that we've covered a lot, and it's not all sinking in, and that's pretty normal. It takes a minute and some practice, so which is what you guys are going to get. So it'll eventually, more and more will be absorbed. So just want to like assure you of that. So don't sweat it if this stuff isn't completely clicking yet. So that being said, what we're going to do is pretty much go through some of the same steps from this morning as far as building those queries, but we're going to put them into a Node and Express app. And this is going to lead us to our final piece of the puzzle tomorrow, putting views on top of the Express app. So the question is, how can we simulate using a form to create a new instance of something, or a form to simulate updating something if we don't have views yet? So today we're going to use a tool. It's called Postman, and it's a really, really handy tool. And what it does is it helps to mimic form data or any other HTTP request without having to struggle through creating the forms first. So, we've got a lot of moving parts, right? We did the Mongoose queries. Now we're going to try to put some Express routing. Then you've got views. So you're juggling all of these, pieces of your application. And it's really hard to make sure they're all working correctly if you do them all at once. It's making your haystack really, really large when you're trying to find the needle or the error. So the idea is, let's make that haystack as small as we can and move in smaller steps. So once we have our queries working, let's put it into an Express app. Once our routes are working, let's put some views on top of it. So it's a very thoughtful way of kind of testing our code as we go along, which is kind of a recurring theme of this class. So I just put the README for this lesson, posted it there in Slack again if you want to follow along. But for this one, we're pretty much going to get right to it. I have some starter code, and it's kind of the shell of a Node Express app. And today we're going to focus on building routes for the Mongoose queries that we created earlier. There's a little bit of an intro here. I think we've pretty much covered. Yeah, I think we're good. I've talked your heads off. Let's just build an Express app. That'll be more fun anyway. Let me put in the prompt to get set up. So again, I'll share my screen and walk you guys through this, and then give you guys a few minutes to get up to speed. So I put some starter code in your week 7, day 4 student labs folder, and it's called Express Mongoose Lesson Starter. So before you do that, let me share my screen and get mine set up and kind of walk you through it. So bear with me. And if you did a git pull upstream master recently, you should have it already. You should have it locally already. But let me cd into this folder. I am going to create if you look in today's week 7, day 4 folder, I created an instructor examples folder. So that's where I'm going to be building a version of this app. And then, of course, I will push it up after we're done today. So just let me open that up. Cool. Let me get my window set up. Just bear with me. Make sure I have all my windows nice and proper for y'all. Nice and proper, like. Okay, I think we're good. Okay, we're a go for screen share. Go for screen share. Here we go. That's beautiful. Okay. All right. So here's kind of the structure of the app. We'll walk through the specifics once you guys get it up and running. But you want to cd into the folder and then run npm install. And that'll go through our package.json and make sure we have everything locked and loaded. Step 3 is to open the app in Atom, which I've already done. But step 4, I really want to be conscious of this. So you guys should have 4 tabs open for this lesson. The first tab is going to be Mongoose. You should already have that open locally. But that's going to be the server tab for your for Mongo. That's going to be the Mongo engine running. So that definitely needs to be running in the background. So let's open one tab for that. Let's open a second tab so we can run nodemon server.js. So since we're running an Express app, we're actually going to run nodemon. So we want to have that in a separate tab again, so we don't have to like Control C and stop our server just to add some new data at the command line or new commands. So those are 2. 3, we may not have time to go into that, but if we do go into the Mongo shell directly to look at our data like inside the engine, it's a good idea to have a third prompt open just so we don't have to like stop some other process to go in there. And then 4, I would suggest that you keep a 4th tab open at the command line prompt so you can create, touch new files and such without having to stop anything else. That's how I like to work, so I don't have to stop some other tab from running. So go ahead and yeah, that's pretty much it. So let me give you guys a few minutes to get set up. So just open Atom and make sure that your 4 tabs are open in terminal. And if you run nodemon server, it should run correctly. Another thing to note for today, this app runs on port 4000 instead of 3000. So all the commands, it's going to tell you to go to port 4000/something. So just don't want to trip you up. I just had run this on port 4000 when I was doing all the screenshots. So it was kind of a pain to go back and make new screenshots. So I just want to let you know, this app will be on port 4000 instead of 3000. Let me stop my screen share while you guys get set up. And I'll put a prompt into Slack so you guys can give me a heads up, a thumbs up when you are ready to rock. Here we go. All right, folks. 5 thumbs up. So just waiting on a few more folks, and we will move forward. Cool. 7 thumbs ups. So I'm going to go ahead and move forward. And at the next stopping point, happy to get you guys up to speed. I'll wait. Yes. That is a resolved promise right there. So there's definitely some, we don't really have time to walk through all the ins and outs of the starter code. It's pretty similar to what we did this morning, but I'll talk about the differences as we go through this lesson. For example, if you look in Atom, this app has a models folder, a models directory. So there's not a lot of magic going on there. As you build more complex applications, if you recall earlier today, we put some schema information in the schema file, and that compiles into a model. Now, earlier, we just did all of that stuff in schema.rb, which is fine and it works. However, as you scale up your full stack application, it's going to be best practice to put your actual compiled model in its own folder. So that is what's reflected here in this starter code. So the models folder has an item model and a user model, item.js and user.js, because those are the 2 things we're going to be playing around with this afternoon. But don't let the separate model files trick you up. We could have put that code in our schema.js just like this morning, but as we grow in complexity, we just want to keep our stuff, the separation of concerns. So I want you to see that pattern, because you guys will probably want to use that pattern for your projects and such. Okay, that being said, I just wanted to point out 2 quick things before we start coding. And the first is I wanted to point out, if you guys want to go ahead and navigate to the database schema.js file, I just wanted to point something out to you briefly, a cool feature of Mongoose. As soon as this image will upload. Come on, dude. Awfully slow today. I'll try this one more time. If you're following along in the README, I guess I can just explain it. Just bear with me. Let me try one more screenshot. Luckily, I do have a backup app that I use when Mag 2 Imager gives me issues. I don't know if it's Imager or Imager, you guys. Somebody wants to let me know, please do. But there we go, finally. So just wanted to point out this bit of code in the schema.js. Just want to point this out. Again, you don't have to like memorize this or whatever, but I mentioned earlier this morning that it's a good practice to add maybe created at and updated at fields to your documents in your database. Now, when we get to Rails and Postgres and such, it has mechanisms that will add that automatically. We don't even have to ask for it. But Mongo doesn't do that out of the box. Mongoose doesn't either. So if you check out this user schema.pre method, so .pre is a method that Mongoose gives us if we want to do something in between instantiating a new record and saving it to the database. So we can put functionality in between those 2 states. And this is a really good example of that. So essentially what this block of code is doing is it's just going to create a new date. So date is a constructor function. So essentially anytime we save something to the database, the first time we save it, it's going to create that created at field. And then it's going to add the updated at field. And so every time we, the created at will only be set one time, right? The initial creation. But that updated at, every time we save something to the database, it's going to check and update that field. So I just wanted to point out this, this bit of code, because that's what this is doing. And you may want to have something like this in your applications. It's a really good practice. So that's the first thing I just wanted to point out. And the second thing that we haven't had time to really dig into today is validations, which is really important. You don't have to use them, but it is definitely a good practice. So I want to show you an example of a validation that we have in this app. It is in, well, still in the schema.js. So look at our user schema. So the fields that we're going to use for user schema are, first name, last name, email, etc. Now the email field, there's a little bit more of, there's an object as the value of that email field, right? It says type equals string. Here, I'll paste it into Slack just so we're on the same page. So it says email, and then there's an object, right? It says type of string. That's the data type. Required true and unique true. So required and unique are both validations that Mongoose gives us. Required means the email is required anytime we create a new user. So consider that when you sign up for Facebook or for some service, usually you can keep some of the fields empty, maybe they're not required. But to say something to the database, you probably want to have at least one field required. Otherwise, how else are you going to save that user or keep track of that user? Generally, like email or a username, and also password would probably be required, but we're not using passwords in this app. But that required just means that this record is not going to save unless that email field is present. So it's required. The other validation is called unique. So that's a really important validation, right? You don't want to have two users with the same email address. That's going to cause issues. Facebook doesn't have two users with the same email when you log in. GitHub doesn't have two users with the same email. So that's another way, again, generally applications will use your email as kind of like, this is your identifier. And so these are just two examples of validations. Like I said, we don't have time to really go down the validation rabbit hole. However, they're super important. And if you go and look at this morning's lesson, if you scroll down to the very bottom, there's a whole section on validations. So if you want to investigate that on your own time, I would encourage you to do so. But just a couple of, well, actually, I'll ask you guys and put these into Slack. What are some instances, either in apps that you use or apps that you intend to build? What are some scenarios where validations would be really important? What would be some reasons to build validations into your forms or into your app? Can you guys think of any specific use cases to add validations for your data? Yeah, that's a really great one, Alan. Yeah, if you wanted to have a password that must contain certain characters. So have you guys heard of regex, regular expressions? Anyone heard that term? We'll talk about that probably in Unit 4. But it's just pattern matching. So, nowadays when you create a password, it's like, must have upper and lowercase, must have characters, right? So that's a really good condition. So you may want to make sure that that user's password, meets some sort of requirements. Yeah, for sure. Any other thoughts on why we may, how we may use validations in our app? Maybe when filling out required form data. Yeah, absolutely. So yeah, certain fields are required. I don't know, maybe if you're filling out a DMV form, like your address and state and zip code, like you're probably gonna have to give them that information, or maybe your social security number. I don't know. Yeah, checking to see if a username exists. Yeah, so that's a really good database check, right? So actually, before I save this to the database, just let me see if any other document has this username. Yeah, absolutely. That may be a good .pre method as well that we just talked about. You know, we're doing .pre to add a timestamp. Yeah, maybe you want to make sure before you create a new record that that user doesn't exist already. Yeah, those are really great. Here's just a couple more that I was thinking about. You guys pretty much hit these. So making sure that a unique email or username, that it's a unique value. Maybe making sure that an email field has an @ symbol, like just so there isn't a typo. Confirm that a phone number field has the correct number of digits. So maybe, how do you want it formatted? You want the area code in there, you know, making sure fields are not left empty. Make sure a password matches this confirmation field, making sure that matches. And maybe you want to have a password have a minimum number of characters. So if you have a minimum of 8 characters and the field has 6 characters, you know, obviously you want to like raise an error or give them a prompt or something. Yeah, cool, great. So again, validations are super important. Maybe I'll find some reading for you guys, but the Mongoose documentation is really good for validations. You can kind of see all that's available to you. Yeah, cool. So that's validations. All right, let's do this. I'm going to share my screen and we will get to it. So bear with me just a second. Let me get set up here. And so we'll do like we did this morning. Give me one second here. Make sure I copied, so I copied some of the starter code for me to work on. Just let me make sure that I set that up correctly. Okay, I think we're good. Okie dokie. So let's move forward. So step 1, let's seed our database first of all. So you guys can just do this along with me. So let's run this command to get some dummy data. We've already walked through the mechanics of creating new users or students or projects, but go ahead and run that file and that should seed our database for you. If you check out the seeds.js file, there's some code in there to create new instances of users and such. But let's go ahead and do that first of all. So you should see something like this. I'll put a screenshot into Slack. So if you see that, then it's successful. So we're creating 3 users. Don't worry about the nulls. The nulls have to do with, there's also a .remove method. So when you delete all of everything, .remove, there's nothing to return. So the default return from our database is just null. So that's what those are about. So we got 4 thumbs ups. And for today, we're pretty much just going to be using the users controller file in our controllers folder. So if you're putting code anywhere else, don't do it, because we should only be playing around with our users controller file to make things easy. Or easier, rather. Okay, we got 6 thumbs ups. Cool. So I'm going to move forward. So here's the first route that we're going to do. Let me go ahead and share my screen. And if you guys want to hang tight for just a minute and let me throw this in my app and then give you some time to add it as well. So like I said, if you want to open up your user's controller file, this is pretty much where we're going to put all of the routes with those Mongoose queries baked inside them. So I went ahead and gave you guys some prompts. These are all the routes that we need to get through this afternoon. And the first one that we're going to work on is the index route. And the code is there in Slack. And let me type it out. I would ask you guys to do the same. But up here at the top, we're requiring, or we're bringing in our Express router. So this code should look familiar from last week. Our index is going to be a get, right? Jeez, I need an energy drink or something. So this is going to be the basic shell of our route. And then inside here, this is where we're pretty much going to like dump that Mongoose query. Pretty much what we did with student model, we're going to be doing the same thing for each route. So our index route grabs all of something, right? And so in this example, in this app, we're going to use users have many items. So instead of student model, the model we're going to use here is user. I could have called this user model just for whatever reason. I'm calling this user. So again, this is the same code we used earlier. I'm going to do a user.find because I want to grab all the users. And I'm going to use the exec promises, the Mongoose built-in promises. And then like we've done like 4 other times this morning, this is going to take 2 parameters. The first is the error object, and the second is whatever is returned from this query. Now, in the previous lesson, we used the word docs, D-O-C-S, for documents. For this lesson, I'm just going to use user or users, okay? You could use either one, but since we're grabbing all the users, I'm going to use users as the parameter to pass in. So for the previous lesson, we just console logged everything. But now since we have Express, not only are we going to console log this information, but we're also going to play around with that response.send, because now we're actually going to be able to send this data to a view that we'll add on tomorrow. But we're actually going to see this data in the browser here in a second. So you guys remember our boilerplate? Man, I could definitely do this part in my sleep. Our error handler, and then for all of these, I just like console logging to my server logs since we don't have any views yet. I'm just trying to be redundant here. And then let's do a res.send, and let's send that user's data. And again, we're just, tomorrow when you guys add views, remember that you're going to do like a res.render. You're going to pass in the path for the view, and then you're going to bake in, the user data into that view. So that's where we're headed tomorrow. So let me save that, and here's how we're going to test out these first 2 paths. Is if you go to localhost 4000 /users, so all of these paths are going to start with /users. We get an empty array. So why is that? Did I seed correctly? So we should be seeing 3 users. Well, 1 second. Let me check my database. I may need to reseed for some reason. So for this one, we're going to use the family tree. That's the name of the database. I should have updated that, but if you look in your schema.js, server.js, you'll see the name of our database. Hold on one sec. Hold on 1 second, friends. 1 second. I updated one of the databases, but we may need to update both. So bear with me 1 second. Let's do db users dot find. Okay, it's not in there. Bear with me. Okay, here's what I did. This is my mistake when I updated this lesson. So if you look in server.js, we have the path of our database. So the database that I want to use is Express Mongo Lesson Starter. I just wanted the database to be the same name as the folder that we're working in. But if you look in seeds.js, I didn't update the name of the database for my seeds file. So when you run this seeds file specifically, we need to tell it what database to seed into. So that's my bad. So let's go ahead and update this so we're consistent, and I'll walk you guys through it. I'll paste this into Slack so we can update it. So not only do we want to use this database for this app, but we also want to seed our data into this database. So go into your seeds.js. I'm going to paste this into Slack, and I'll make sure everyone's good to go. Just go into seeds.js, and on line 2, where you see that mongoose.connect, just update it with that line of code that I pasted. We just need to tell it which database we want to use. So now I think if you do that, and then we refresh, I'll try to reseed real quick. And I'll walk you guys through all this. I usually think of everything, but sometimes don't think of everything. Cool, so I just ran seeds.js again, and I seeded that new database. So now if I refresh my browser, there's our users. So we just need to change that database path. Yeah, thanks, Cody. So we just want to replace, so go ahead and replace that, and then run node seeds.js. And then if you refresh your browser, you should see something like this. So the seeds did work correctly. We just seeded, we had a different name for that seed database. So we just needed to update that.
Mark, yours looks like that because you have a plugin, right? A JSON plugin?
Yeah, I thought I talked about this before. This is a plugin called JSON View. It's a Chrome extension. I highly suggest you guys add this. It's super handy. And let me Slack out the extension. I love this plugin. Yeah, JSON View. So let me Slack this out. Yeah, it makes reading that JSON a little cleaner. There you go. Yeah, so if you guys want to install that, pretty handy. So give me a thumbs up in Slack when you see something like this. We should all have the same data. However, your underscore IDs are going to be different just because you have a different local version of Mongo. But all of the rest of the fields should be similar. The names, the emails, and stuff, because all this is from the seed. So Audrey, go to /users and see if that fixes. So you need to go to localhost 4000 /users. And see if that helps. if you go to localhost 4000 / users and you don't see that data, let me know and we'll troubleshoot it.
So Mark, I don't see that data, but I am getting exactly what you're getting in the terminal, which is like null and then the 3 users created.
Okay. Sorry, who said that? Was that Sophia?
Yeah.
Go ahead and share your screen. We'll take a look at this. Yeah, Cody makes a good point. You want to make sure that your server is running. You'd probably get some sort of error. Well, yeah, you would get that can't open the get. Okay, cool. So go to your, so you updated your seeds.js. That's good.
I think you have to run your server.
Yeah, it is funny though. So, I mean, I figured I'd just follow with Sophia. It might be the same.
Yeah, so Sophia, you have your MonGod server running, but we need to run NodeMon in another tab. So go ahead and click another new tab. Yeah. So let's run NodeMon server.js and then refresh your browser. I think that'll take care of you. Okay, can I get users? That's okay. So let's go to, actually go back to the browser, Sophia, and get rid of that last /. I don't think that would really affect it. Oh, I'm sorry. I haven't given you guys a chance to create that route. That's my fault. Sorry, my bad. So just sorry guys. Who cannot see the JSON information in the browser? I see 5 thumbs ups. So Sophia, you may want, I'm not sure, I didn't get to see the code, but you may want to flesh out that router.get route.
I just did that and it worked.
Okay, good. Yeah, my bad. You hadn't gotten that quite that far. So we see 5 thumbs ups. Audrey, you can go ahead and share your screen. We'll take a peek.
I was following along with Sophia. I think mine was the route thing as well. So I'm going to try that first.
Oh, cool. Okay. And then who else? Is anyone else having difficulty? Yeah, Kieran, what's going on? Clean exit. Okay. So I'm gonna go ahead and get you guys started on the show route. Actually, let's do this. Why don't you guys, the next route we're gonna build is show. So given what we did this morning and given the index route we just created, go ahead and see if you can create a show route that will show 1 user in the browser. And if you look in the lesson, I'll paste it into Slack. So remember that the ID of these folks is that crazy hash, that _ID. So what you're going to want to do is when you have all your users loaded up in the browser, just copy the _ID of one of them. And I'll paste this into Slack. And then do localhost 4000 / users, and then paste in that crazy ID hash for one of the users, and you should see something like I just pasted into Slack. So if you notice, right now in the browser, when you pull back all your users, it's really an array of users. So you have a little opening square bracket and a closing square bracket. But if you look at this screenshot, it's simply an object because we're returning 1 of something. So when we return 1 object or 1 document, it's literally going to send it as the object. It's not inside an array or anything. So we can't iterate over it, nor would we need to. Just a really small difference there. Yeah, so Kieran, we may have not saved a file correctly or something. If you want to share your screen while folks are working, we can debug it. Okay, so let's check your terminal. Let's see what's going on there. Okay, so you have MonGod working. Okay, that's fine. So yeah, you do have your 3 seeds in your database. That's good. I think NodeMon's working okay. Let's go in the browser. Can you go to localhost:4000?
Let's see.
Okay. Okay. Let's go to your to Adam.
Can we try something?
Sure.
Can we view the terminal with 2 tabs?
Yes.
Can you control C that? And then go back to the other terminal with 1 tab. Start NodeMon again. Yeah, all right. Mark, what were we gonna try in your Atom?
Kieran, it's NodeMon, and you have to tell it the file name that you actually want to run. So let's do NodeMon. So let's do a Control C to get back to the prompt. Let's run NodeMon server.js. Okay, so refresh the browser. Let's see if that does anything different. It looks like it loaded it just the same, but.
Yeah. Can you go in your Atom this time and go to your package.json?
Where's the package.json at?
Yeah, towards the bottom. All right, it says server.js. Can you go back into your single terminal? Control C and LS.
I think I'm in the wrong thing again with this one.
Yeah, I think you're supposed to be on Student Labs and Express Mongoose Lesson Starter.
So Kieran, the name of the, it's Express. You're already in the Student Labs folder. So we need to CD, just start typing EX and hit tab.
EX?
Nope. CD space EX and then hit tab to auto-complete it. There you go. All right, hit enter. Okay, so had you put any code in here yet, or were you working in the other directory the whole time?
Yeah, I did in that. So I've got the 3 tabs open, so I did it in the other 2 and not in this one.
Okay, so if you have the lesson README open, just do me a favor, start at the top of the README, or if you want to look in Slack, and just try to walk through those steps and get up and running. So you want to open the 4 tabs.
Let's see.
Cool, we got 1 thumbs up. Nice work, Matt. Ooh, Alan, nice.
Okay.
Okay, so open up another tab, Kieran, in the terminal.
Yes, I've got that one.
Okay, so it looks like, okay.
Let's see.
But okay, go back to the browser. I think looks like you're able to load. Yeah, so you are getting stuff. Can you go into Atom, into your lesson starter, Express Mongoose lesson starter code? Did you already have the index route created? If you go into users controller. Oh yeah, cool. Okay. Yeah, so it looks like you're in good shape. So your folks are rendering in the browser, so that's good news. Yeah, I think you're good, man. So right now we're just working on the show route. So see if you can create a user show route. You can just put it under the prompt right there on line 17.
Yeah.
And we'll walk through it here in a moment, but see if you can take a stab at that. But yeah, you're in good shape.
Good to go.
And so for those of you that are done with the show route, we'll take another minute or two, and then we'll walk through it together, then move forward. But if you're done with the show route, go download this tool called Postman. So this is the tool that's going to allow us to mimic form requests, delete requests, and such without having views and forms. And this is a super handy tool, and we're going to use this next to test out our update and basically pretend that we have a form when we don't. You guys will actually create the forms tomorrow, but go ahead and download that. All right, we got 4 show routes. Cool. Yeah, especially during group projects. Yeah, Postman's a great tool to test out your routes, test out the functionality of your app before you start trying to throw views on top of it. So it's a good thing to test out everything before you start the complexity of rendering views. Yeah, it's also a Chrome extension. I would just download the OS X version. Either one's probably fine. I think mine is technically the Chrome extension version because I downloaded it a long time ago, but it should be the same thing. I think you can get it through the Chrome store. Yeah, you could brew install it as well. So take another minute or so on the show route, and then we'll walk through it together, and then move forward. So I know we've covered a lot today. We're probably going to, no matter where we are, I'll probably cut us off at like 5. So we're going to have like an abbreviated lab time. But if we don't get finished by 5, we'll just pick up tomorrow morning. But I think we can get through the content by 5. I'll give you guys a little break here after the next section. Okay, so we have 5 thumbs ups on show. Let me, the code is there in the README, but I'll paste it into Slack just for your enjoyment, if you will. Here is our user show route. So there you go. So it's the query. I think this morning we used the Mongoose find one query. But now that we're actually, or the find one method to query the database, this one actually uses find by ID. Either one is fine. But as we build up a RESTful app, it's probably going to be quicker and easier to use find by ID and just pass in the ID of whatever user or individual instance that we want to view. So you could use find one if you want, and then look up whatever user you're trying to find the way that you want. But I'm going to be using find by ID today. We grab, yeah, IDs are unique. So there's probably less than 0 chance that 2 people are going to have the same ID for sure. And then I'll let you guys read through this code. Find by ID, we're grabbing the ID from the request parameter object. This is pretty similar to what we were doing last week with Express. So that should be familiar. And we're just passing that ID to the database. Find me the user that has this specific ID. So that's how that is working. Cool. So if you don't have that code, if you want to grab that, feel free to, if you want to finish typing it out or just pop it into your user's controller and we'll move forward. And then our next step is actually to download Postman. So if you haven't downloaded Postman, please go ahead and download that because we'll need it for our next few steps to test out our stuff. And give me a thumbs up when you successfully downloaded Postman. Or Postman, however you want to enunciate it. So we're going to use this tool Postman for our, the next route we're going to create is the create route with a post request. So we're going to walk through using this tool to mimic a form, sending form data. So that's what we'll do next. So I see 3 thumbs ups on Postman. Cool. Let me see if I can fit this all on one screen before I screen share. Okay, cool. So just to recap kind of what we've done. So the first step that we did this morning was play around with the Mongoose queries to get familiar with that. Step 2 we're doing right now, which is where we're taking those essentially the same queries and wrapping them in express routes so we can send and receive, the appropriate data. And then tomorrow we're going to put views on top of all that. So again, we're trying to be very deliberate about how we're stacking our application. So we've done index and show. Let's take a look at a create route. And to do that, we're definitely going to use this tool called Postman. So let's build the route first, and then we'll walk through using Postman to test it out. So feel free to follow along with that screenshot I put into Slack. I'm going to share my screen, and I'll just talk through this code as I type it. And let me know if you guys have any questions. So this is going to be our create route. I'm going to put it right down here underneath this prompt. Cool. So this is going to start with a router.post. And this will just go to /. Cool. So hopefully that's pretty good habit. We're getting into, this is the, kind of the shell. One sec. Guess both my things are dead. That's all right though. We're going old school. Old school. I feel so inhibited. Okay, can you guys hear me? Okay, cool. Both my AirPods died. Write a strongly worded letter. Okay, so this is the shell of our route. We're going to do a dot post. And then here inside it, we're going to add the query that we built earlier this morning, essentially. But before we do that, how are we going to create a new instance of a user? Well, now that we're going to be dealing with Express, ideally this information is going to come via a form, right? It's going to be sent in the request, the body of the request. So the first thing I want to do is mimic grabbing the body of that request and instantiating a new user object that will then save to the database. So the way that we're going to do this is let's create a variable user, which is essentially going to be a new constructor for our Mongoose user model, like so. And then our users have a couple of fields. So it has a first name. First name is going to be, so this should be familiar from last week. So we're going to have a form field for first name, and we'll grab that from the request.body object. So you guys can probably figure out the rest here. Let's do email, and we'll do items. So items is going to be an array of embedded documents that we'll build. So the email will be request.body. We'll grab the email field for that one. Then items will be request.body items, like so. So the first thing we need to do is just grab the request.body data from a form that we're going to get, and then create a new user out of that form data. That's the first step. And then the second step is we're going to call save on this. So this should be familiar from this morning. I'll do user here. So it's the same pattern. User.save takes a callback right here. We'll pass in the error object if there is one, and whatever is returned, or whatever we're calling user.save on is what gets fed in here as a second parameter. So we'll do our good times error handler here, which I think this is like the 7th time we've typed that. So we'll console log any errors, and then I want to console log my user to my server logs just because, just to check it out. And we're also going to res.send our user. So once we create a new user and save it, I want to see that new user object that I created. And so this is what our create or our post route is going to look like. So give me a quick thumbs up in Slack if you've added this route like the screenshot there in Slack. Just give me a thumbs up before we move on to test this route. Cool, so we got 5 thumbs ups. And then for the next step, if you want to go ahead and open Postman, we're going to test that post route using this tool, because we don't want to deal with like creating a view and a form. It's like a whole other can of worms. We want to make sure that this route is actually functional before we try to struggle with creating a form and a view for it. But if you open Postman, just to get a sense, there's a lot of bells and whistles on here. So I'm going to like walk you through precisely what we need to do, because there's if you hit the wrong type of form and such, your stuff's it's not gonna work properly. So very elaborate interface here, but we'll walk through what we need to know. But just to get started, the quick and dirty here, these are all your HTTP verbs, all the various requests that you can make with this app. So generally we deal with get, post, put, patch, and delete, right? But there's more HTTP verbs if you're interested. To build a CRUD application, and for the scope of this course, we just deal with like these first 5. Really 4, put and patch for our purposes, pretty much the same thing. There is a subtle difference, but either one of those would work with an update. But just to kick the tires, you select the HTTP verb, you pair that with whatever route you want to hit. So right now, we're going to hit our Express app, which is at localhost 4000/users, and then you can hit send. And that's going to mimic what the browser would do, sending a request. Now the browser does get requests. We've already tested this route out, in our browser. We can do get requests all day long. What we can't do are deletes, posts, things like that. The browser doesn't have that functionality. But if you hit that route with the get request and hit send, you should see your array of 3 users. It should be the same data that you see in the browser, but if you just want to kind of get a kickstart on that. But that's not why we're here, folks. We're here to mimic a form and try to create a new user. So here are the steps we're going to walk through. If you want to just watch me for a second, and then you can walk through it. But step 1, since we're trying to, again, we're testing out this route right here, the create route, which is a post request. So the first thing I need to do is make sure that I select post, because we're going to try to hit that route. The second thing that I need to do is make sure that my URL is correct. So this is accurate. I'm sending a post request to localhost 4000/users, because that's where it needs to go. So far, so good. All right, so here's the tricky part. So just pay attention to this, because this sucks if you do it wrong. So hit this body tab right here. And the body tab is going to open up another little section. And this, just pretend that this is like a form. So you can write whatever form fields you want and values. And this is going to wrap that data, and the server is going to receive it the same way if we had created a view with the form inside it. So you need to click on body, and then we need to make sure that we click on this x form URL encoded. So for some security purposes and such, this is the one that I know is going to work. So we're going to go with this one. So make sure that you select the body tab and then this form URL encoded. Now, I know that my users have a first name. So let's create a new user. I'll do first name. My go-to. I don't want to do Schmitty today. I'll do Rihanna. So I'm going to do first name, and the value, just like I'm mocking up a form and putting it in the input field, is going to be Rihanna. And then I'm going to create another field. Now, the validations that we put on our models, we have to have an email, right? So this is going to fail unless I absolutely have an email as required. So let me do riri@ga.co. And that looks pretty good. We're not going to deal with items right now. We'll play around with that later. And that's not a required field anyway, so who cares? And once we do that, we should be good to go. So let me hit send. And there we go. So the code that we wrote, if this is successful, we res.send our new object that we just created. And so this is the new object. I know it's been persisted because it has a created at, an updated at, and an ID. And then I can see first name Rihanna and email of riri@ga.co. Now, if I want to test that out a second time, just let me refresh my browser where I'm loading up all the users. And right here at the bottom, the newest one I created is Rihanna. So I know that it's persisted. So that is how we create a new instance of something using this very helpful tool called Postman. So let me stop my screen share and give you guys an opportunity to walk through those steps. If you want to create 1 or 2 users, go crazy, go nuts. And then ping me if you have any questions. I'll put the prompt into Slack, and then please let me know once you're able to successfully create a user using Postman. And again, Postman is a super handy, super powerful tool, but there's a lot of bells and whistles. We're only using like a small portion of its functionality, so it can be confusing sometimes. There's a lot of knobs to push, if you will. But we'll get the hang of it. Yeah, so go ahead and give me a thumbs up in Slack if you're able to successfully create a Postman user. And if you do get that working, let's take a 5-minute break. Again, I'm just gonna stop it at 5 o'clock, and we'll pick up where we left off tomorrow. But go and take a 5-minute break if you want to stretch around, stretch the legs and such. We've been going pretty hardcore today. So Kieran, the reason that it's breaking is because we don't have a last name field in our schema, in our model. So I would try using first name just to make sure it works. You can totally use last name if you want, but you just need to add it to our model, to our schema.
Also, we can't duplicate emails because we had that validation there.
Yeah, good point. So the email has to be unique, and it's also required. So anytime you try to submit that form, it's going to require an email. Actually, we'll see when we get to the update. Even if we're updating an existing record, we're still going to have to send email along with it. Otherwise, it's just going to like override it. We'll see that in a little bit. Yeah.
Yeah. In the schema, we actually do have a last name. We just didn't put the last name within our new user parameters or constructors.
Gotcha. Yeah, so you can put it in there if you want to. I think just to keep it simple. Yeah, in the seeds file, I tried to keep simple, so I didn't seed our database with last name. But yeah, if you want to update that, you can totally go for it.
Hey, Mark.
Yeah.
Do you mind if I share my screen real quick? I am a little confused with how to use Postman.
Yeah, that's no worries. It is pretty confusing.
So I have it open, and I've got it listed as posts, and I've got the local host users, but nothing is showing up in body.
Right. So click, you see that authorization? Click on that body tab. So go over to the right.
Ah, I see it.
Yeah. And there you go. So you may need to like make that section a little larger.
But yeah, that's where the kind of the mock form, the key values pop up.
Okay. So then after I selected this is where I enter those values you're talking about.
Right. Yeah. Yep.
Gotcha. Cool. Thank you.
Yeah, you got it. Yeah, I mean, no joke. Postman is definitely there's a lot that you can do with it. So there's a lot of bells and whistles. All right, let's move forward. So like I said, we'll put a pin in it at 5, and I want to put you guys into breakout rooms. This lesson is pretty. The code works. It's pretty laid out for you, and so I think that you guys will be able to follow along pretty well. And I'll be around if you guys need help. But we'll do that at 5. So Cody, if you're there, whenever you're there, if you don't mind, would you mind making some breakouts?
I got it.
With our buddies.
Affirmative.
Go for buddies. We are go for buddies. All right, man, long day, getting loopy. You guys are doing great. So let's take a look at our update. And this is another method that we'll test out with Postman. And we'll see how to do that. So let's do that next. And I will start my screen share. And if you guys just want to follow along, that's totally cool. I won't make you wait. I'm going to put my user route down here at my user update prompt. So for update, there's a couple of different methods available to you to update a document. You can use find by ID in update, which would require that crazy hash, the ID, or you could do that find one in update. So if you wanted to find the record again by like first name, find Johnny and update that one. So either way is fine. However, it's probably going to be, now that we're dealing with Express, we're probably going to want to do stuff with an ID because it's going to be a little bit more unique. It's definitely going to be unique. And then it's easy to grab that ID from the URL parameters. So it's the path of least resistance. So let's create a router.patch for our update. And for this one, we need to pass in the specific ID for the user that we want to update, obviously. And you guys should be doing this in your sleep. So we'll pass in request response, and we have our shell for our route. Cool. And then let's play around with the Mongoose query to grab that user and update him or her. So we'll do user dot, and let's use that find by ID and update method. I really like that one. So this method already assumes that you're going to pass in an ID as an argument. So we'll do request.params ID. So we'll grab the ID from that params. Very similar to what we did for our show route up here, right? Just grabbing the request.params.id. The same principle. But since it's an update, there's a couple of more things that we need to add. So if you remember earlier today, when we do an update in Mongoose, we need to pass in the new data that we want to update. And then if we want to return the new version of that data with that extra new : true. So let's build that out. The first thing we're going to do is let's create the information for the update that we want to do. So if we're going to get the form data, let's go ahead and pass that in as an object. So our form is going to have a first name, and that first name is going to be the request body first name. And we'll also send an email field. And again, we have more fields if you look in our schema, but just trying to keep this simple. But we have to have an email field because that's required. So if you recall, we put validations on email to see how that works. So emails are required and they have to be unique. So we definitely need that, and that should be the email there. And so remember, this takes a second object. This is optional, but I want to see the new version of that object that I update. So I'm going to pass in this other parameter, new : true. So Mongoose, send me the latest and greatest with that. Cool. So this is our query. It's on a couple of different lines, but don't let that scare you. It's all kind of the same thing. But this query, again, it's going to run this, and then let's attach a promise to it so that we can do something once that is completed. Because I don't know how long it's going to take. And this may be like the 20th time we've typed this today. So we have our .exec, which is the Mongoose promise method. That takes a callback that has error and user parameters. Again, I'm just calling this a user because that's what we're updating. You could call this whatever you wanted, really. And then down here, you guessed it, let's do our error handling. Awesome. And then we'll do the same thing we've been doing all day long. Let's just console log the user to the server logs, and then let's also do a res.send of the user. So Mongoose, once you update that user, just send me the updated document. Let me see what it looks like. So that is our route. Now let's test it out. And the way that we're going to test it out, let me scoot over here to our other window. The first thing we want to do, I'm going to use Riri. But remember that you guys are going to have different IDs than I do because your Mongo database is something different. So just pick one of your users and grab the ID, the underscore ID of that user. Because when we update something, we need to tell Mongoose the specific user we want to update, right? I'll play around with my precious Riri. So I'm going to grab that ID, and to grab the information for her, I just want to confirm this. Let me do a GET request to /users and then her ID. Just let me make sure that everything's wired up correctly. And indeed it is. I assumed as much. So I did a GET request. This is hitting the show route. So show me one instance of a user. And this is Rihanna's ID. So I just wanted to confirm that before I move forward. So once we do that, we're doing a patch request. So if you remember when we built this route, we did a .patch. So we want to make sure that we're hitting that specific route. And the route is going to be /users / the ID of, whatever document we want to update. So once you do that, let's make sure we go to the body tab and make sure that x form URL encoded is selected. That's how we need to send this data. And let's just update her name. I don't know. I guess we'll call her name Riri. I'm running out of creativity. It's late in the day. The one thing I will ask you guys to do is make sure that you also send the email field back. Because if we don't send the email field back with our updated information, you're just going to get null for email. It actually just like erases it. But generally, when you load up a form, you're going to load up all of that user's information, and you're only going to change the pertinent fields, right? But all of that data gets sent back. So that's kind of the idea here. So even though I'm not updating email, I'm going to still send that back with my request. So that looks pretty good. Let me go ahead and send this away. And the response that I asked for is the updated document. And so now I can see that the first name was updated to Riri. Ooh, I misspelled it. Gosh darn. Okay, that's fine. And then also note that since this was an update, that she has the same ID as before. So an update, we're not creating a new instance. We're just updating an existing user. So the ID should be the same. So that confirms that our update's working. Let me stop my screen share and help you guys out with that. You can just update the correct spelling. Yeah, for sure. I'm going to do that now, actually, because that's going to bug me. And luckily, Postman keeps like that data kind of in that form in the key value field, so you can just redo it. Okay, so I just updated it. Whew, crisis averted, you guys. Yeah, so go ahead and make sure that that's working. And if you refresh your Chrome browser, and if you go to localhost 4000 and load up /users, again, it's just going to grab all of the users in your database, and you should also be able to see your updated information as well when you ping all the users. So you should see it in 2 places. And you should also see it in your server logs because we're console logging this garbage, but that's probably a little overkill. Console logging it, res.sending it, but want to be thorough. And go ahead and give me a thumbs up in Slack. Kieran deleted the last name, but somehow still my postman is Borkin. Well, I don't know what Borkin is, but we can take a peek if you want to share your screen. And then keep those thumbs ups coming. I think we'll do actually, give me a quick thumbs up on camera. How are you guys feeling about this stuff? Am I just like talking you guys' heads off? I mean, you guys have pretty much been knocking this out of the park. So
better than promises.
Better than promises, yeah, for sure. So I think what we'll do, why don't we open up the rooms early, because I don't want to be boring you guys. So Kieran, before you share your screen, why don't you guys pick up at the delete method in the README? And I'll give you the specific kind of link in the README where you can pick up. But the only 3 routes that are left are destroy, and then there's some code on how to embed documents. So embed an item inside a user. So you have some reference code for that. So I'm just we'll go ahead and put you guys in breakouts to work on this independently. So go ahead. Oh well, I guess everybody took off, huh? Jesus.
I thought Kieran had an issue.
I know. Yeah, let me pause. I was just sending out like